We are about to start in few minutes. I request everybody, please take your seats. Take your seats. We are about to start in another few moments. Requesting all the guests, all the attendees, everybody, please take your seats. Good morning, ladies and gentlemen. Welcome to Day 2 of National Rubber Conference 2024. Hope you had a fantastic evening yesterday and are all ready and refreshed for yet another day of NRC 2024. So, a very good morning, everyone. Good morning. Wonderful. So yesterday we had some amazing sessions, very insightful and informative panel discussions, and we are yet ready for another day now. So we are about to start with the technical session number 4. And before I invite the session chairperson, Dr. Amit Chakrabarty, to preside over this session, I would like to say a few words about him. Dr. Amit Chakrabarty, Head Research and Development, PCBL Limited, has 25 years of professional experience in the field of polymer science and technology, covering polymer blends and composites, polymer rheology and processing, advanced filler technology, etc., to support, explore, cater product application and business development, investigative research, to expand product and intellectual property portfolio through implementing innovation management. He started his career in DRDO, Defense Research and Development Organization, Government of India, Visakhapatnam as scientist, followed by scientist in John F. Welk Technology Center, Bangalore, and DuPont Knowledge Center, Hyderabad. After completion of his PhD degree and postdoctoral research from University of Calcutta and National Cheng Kung University, Taiwan, respectively. Dr. Amit has 15 journal publications and 4 granted patents. Let's welcome Dr. Amit Chakrabarty with a big round of applause. So please preside over the session.
Thank you very much. Good morning, everyone. Good morning. We have a very wonderful session yesterday. No doubt, yesterday's evening was memorable. Afternoon was very good, and morning also yesterday. We started the program yesterday, the technical program we're talking about, a mix of chemistry and environment, followed by some prediction technology from simulation, then again moved to some chemistry and advanced filler related to silica, carbon black, functionalization, and as well as legal perspective of different aspects. All we have covered. Now this particular session is again, we are going back to filler technology, and how the filler technology can change the face of the rubber. Our theme is resilience rubber, or even navigating the challenges and embracing the opportunities. So let us see how in the next two sessions, two young speakers are there. First speaker is Mr. Pankaj Rai. And Mr. Pankaj, I think he's done his MTech from Rubber Technology Center in IIT Kharagpur in 2010. And his first job was in Oriental Rubber Industries between 2010 to 2017. And currently, he is working as an assistant vice president in Foris Mining and Company International in Sonepat. His overall professional experience is around 15 years, and he covered research and development, quality assurance, then quality management system, and I think he's a go-to person for belt. He has a lot of experience in the belt industries, safe belt, sideward belt, and textile-based belt, and even steel cord-based belt also. So let us welcome Mr. Pankaj Rai to have a first 30 minutes with again some wonderful session, right? Okay, Mr. Pankaj, you can come. I will give an alert to you. Okay?
Thank you. Thank you. Thank you, sir. I confused. I thought he's saying that after. Thank you, sir. Thank you. Good morning, everyone. Thank you very much, sir, for a brief introduction. I hope you had a good sleep yesterday. I am finding some guys, they claim me that they will be first here to see my presentation, and they stop me to take extra drink because my one is the first. So anyway, in starting, I will give a small brief presentation about my company. It's basically for conveyor belt. So basically, we are in this industry since more than 30-35 years, and now you can see, starting with the draft belt, we have a bunch of product available with us. So basically, when we started, we had a very limited export, and we are trying to compete with the various MNCs company. But right now, we can say proudly, right now, more than 30 to 40% export we are doing to the US, Australia, and European countries. And for the special, like steel cord belt, sidewall belt, those belts was not into the Indian market, manufactured by Indian companies. We have the first one, those stabilized these complicated that industrial belts for our industries. Now, beside of my current job responsibility, I am also pursuing my PhD from MIT Gurgaon. So when I joined, I want just to take 2 minutes for this topic. When I joined there, I have joined in chemistry department. Then that professor is done his PhD from IIT Delhi and PDF from Canada. And he has a 25-30 good research paper for the chemistry. And he is a very strong in core synthesis. We know that rubber technology is a blend of science and engineering. Being a rubber technologist, but we miss the science because of that kind of synthesis facilities with us. So when I saw their work, they did lot of synthesis, lot of chemicals, lot of daily new crystals, daily in every 2-3 months, any professor publishing the new paper. But still there is a gap. We are not able to commercialize that research, utilize that research for the industry. So then I thought, we should make a trio. Trio means chemistry, rubber technology, and industry. So I have taken the topic that 2D materials like nitrobenzene, graphene, etc. So I know the challenge. I know the gap. Where is the gap between rubber industry and what we need? That chemist person don't know that. He knows his expertise. So we blend it. So we are planning to synthesize or functionalize the graphene and other 2D structure to get dispersion, because we know the challenge with the 2D structure, the dispersion. We can do at a micro level or in the lab scale level, but when we go to the production level, we are not able to achieve that properties which is basically we desired. So that was the whole idea. When we will, during the research work, our target will be to develop such a product, considering the process capability of rubber industry, considering the cost effectiveness. We will try to develop such a product. Those can be utilized in our rubber industries, and we can scale up. So now coming to today's subject. Yesterday, Dr. Naskar has started with peroxide EPDM curing. Today, I am going to start with the carbon silica dual phase filler. So this work I have done under Dr. Kinsuk Naskar only. So we have 3 chapters. I would like to try complete as fast as possible. So we know of filler. So the major filler is carbon and silica in the rubber industry. So why carbon silica dual phase filler is required? What is that beauty of CSDPF? It was a very nice concept. Somehow it is not yet commercialized, and Kaiwad person people are also present here. So far it is not commercialized, but the overall idea, concept, and the evaluation was very unique. So in CSDPF, what they did, they co-fumed during the production of carbon black. They co-fumed carbon and silica together, and in result, what happens to get better filler polymer interaction, or vice versa, low filler interaction. So they have introduced 2 kind of series named as 2000 and 4000. So difference between these 2 series is you can see the picture. It is 2000 series. So here in this picture, the silica is distributed throughout the aggregate. When we talk about the same image of 4000 series, you can see the silica is concentrated on the surface of the aggregates only. So this is the basic difference between 2000 and 4000 series. Now, this is the nomenclature. That first number is for the particle size, second number is for the particle size, and the last number is for the percentage of silica. So basically in 2000 series, the silica content is 5%, and 4000 series, the silica content is 10%. So that application and that trial we have taken for the trade compound, and precisely the requirement of the target to achieve durability, better fuel economy, and by the same time safety. Yesterday, Dr. Roy from Madhu Silica has already explained about the magic triangle in his presentation. So this is our target, to get by the same time to achieve all these 3 properties. So this is silica, again carbon black, and now the target by using CSDPF to break this magic triangle in all three aspects. So further, coming to the experimental part, we have done 3-stage mixing for the better dispersion. And in testing, we did all the that initial testing, physical properties, Rio, Muni, and the most important factor to understand the dispersion and properties of filler is your Payne effect, and secondly, the DMA. So I would like to start the first chapter. In first chapter, we have taken 5 compounds. First carbon black, second carbon black, second is the silica. Third, we have used the carbon black and silica blend to compare with the carbon silica dual phase filler. Because there is also silica, we have co-fumed the silica with the carbon black in the beginning of during the manufacturing. And here we just taken the carbon and silica as a filler, just we blended with the polymer during the mixing. So this is the typical formulation. And with this carbon silica dual phase filler, we have taken 2 formulations, one without coupling agent and second with coupling agent. So this is the pure characteristic of the all these 5 compound. Now coming to physical properties, so we can see that the compound E, that CSDPF with coupling agent showing the better properties compared to other compound. Coming to that abrasion part, we can say the carbon blacks here showing the best abrasion properties, but the carbon silica dual phase filler is comparable with the silica. Now coming to heat build-up, so we can see that the carbon silica dual phase filler with the coupling agents showing much better properties with the carbon black. So throughout the whole journey, you can see that there is a competition either between carbon silica dual phase filler, either between carbon silica dual phase filler with the silica. So it's compete in some area with the carbon silica dual phase filler, in some area with the silica. So coming to the we have analyzed the Demetia cut growth resistance. So we find that the carbon silica dual phase filler is not that much good as a carbon black, as a silica, but is giving the good comparative results against the carbon. Now, Payne effect. So in Payne effect, basically we do the shear modulus sweep, and the beauty of that RPA, this study, is that it doesn't make any impact on the network of the rubber. It only impact on the filler-filler interaction or filler-polymer interaction. So what we get, because of that that differentiation, we can measure the change in shear modulus complex, and lower the difference, better the filler-filler interaction, or vice versa, filler-polymer interaction. So we can see that the carbon black showing a very high delta modulus, complex modulus, and in the same time, silica is showing the best Payne effect. It's a better filler-polymer interaction. While if you look into carbon silica dual phase filler, it is in between carbon black and silica. And now coming to the next important properties, like rolling resistance. So we can see again the silica has a better rolling resistance compared to carbon black silica dual phase filler, but in that case you can see the carbon silica dual phase filler, because carbon silica dual phase filler is predominantly is carbon black, silica is 5 to 10%. So in that case we can see the carbon silica dual phase filler has much more advantage over the carbon black. Further, we did that aging properties. So all aging properties are comparable. Now coming to the chapter 2. So we have used carbon silica dual phase filler, and that time we have taken the that on the basis of thumb rule, we have taken the percentage of TSPT. Now we have tried to, this is the general chemical reaction was with TSPT and carbon black with silica. So now we have tried to optimize the dosage of TSPT. So in that case, we have again formulated 5 kind of compound. And further we did all analysis. So I would like to explain this picture. You can see the H0 and H2. In H0 there is no coupling agent. And in H2 there is a 2 part of coupling agent. So when we do the microscopic picture of the abraded surface, if there is a good filler polymer interaction, either good coupling, the surface will be more smooth. So we can see in case of H2, the face of surface, the image of microscopy is much better than H0. So it's clearly indicate that it's a good practice to analyze, to understand the filler polymer interaction or distribution of filler. So this is a very, very simple and unique method to understand the dispersion and interaction of the filler with the polymer. Now, again the physical properties, we can see that between H2 and H4, results are optimized. And then abrasion resistance, so again there is a H2 and S4. After S4 there is a plateau, so up to S2 part of coupling and 4 part of coupling, the results are optimized. Coming to heat build-up, so again the trend is same. So 2 part and 4 part is showing optimum results with the coupling agent. Sorry, I hope I'm not going very fast because I need to complete all 3 chapters in that time limit. Again in DMATIA study, so it has been observed that the state graph with the use of coupling agents, as we are increasing the dose of coupling agent, the results for DMATIA cut growth is improved. Sorry, 1 minute. This is the number of cycle and this is the cut length in mm. So basically, it's with the impact of that use of coupling agent, there is a drop, and the reason is that the plasticizing impact of the coupling agent play a vital role to reduce the stiffness and viscosity of the compound. So further in the RPA study, we find that the 2 part and 4 part of with the coupling agent, with the 4 part of coupling agent, it is almost optimized. Even it is based with the 6 part, but you know the TSPT is a costly material, so we need to optimize in terms of cost of the product also. So we can say up to 4 part, the results are optimized and is giving a better properties with the coupling agent. And you can see without coupling agent, results are, the delta G is very high. So there is a very significant impact of the coupling agent with silica and carbon black for the filler polymer interaction. In DMA study, again we have find that for the 4 part of coupling agent, results are better. For wet skid resistance, the higher the value of tan delta at low temperature, better the wet skid resistance will be better. So we can find with 2 part and 4 part, results are comparable. So on the basis of this study, this is the aging properties. So on the basis of all this study, we can see that the 4 part is the optimum dosage with that standard formulation which have been used to get the better and balanced properties. So after chapter 2, I am coming to chapter 3. So in starting, we have talked about the passenger car titrated compound. Now we did work with the truck titrated compound. And for that, we have selected the 2000 series with the less silica doses. So here we have formulated 4 types of compound. In this 4 types of compound, one with the carbon black, second with the carbon black in silica, because with the natural rubber silica is not very much compatible. So we have taken carbon black and silica in blend. Again, then carbon silica dual phase filler with and without coupling agent. So this is the Rio characteristics, and after that we can see the dispersion. So we can see that with the results above the 9 to 10 is excellent for the dispersion of the aggregates. Now again the microscopic picture. So between H and I, H is without coupling agent and I is with coupling agent. So we can find a clear difference between H and I for the dispersion and smoothness of the surface. So further discussion about the physical properties. So we can find that with the compared to carbon black silica phase dual phase filler with the coupling agent showing a better properties. And in terms of abrasion index, the carbon black's dual phase filler is slightly better than the carbon black and significantly better than the other compound. Now coming to the heat builder parts, so except the compound H, all results are comparable. When carbon black is showing better results compared to in carbon silica dual phase filler. Now coming to that pan effect, so in that case we have observed that the carbon black silica mixed compound and carbon black silica dual phase filler results are comparable in terms of rolling resistance. The compound with carbon black silica dual phase filler is showing a much better results compared to all other three compounds. This is the aging properties. Further, in conclusion for the chapter 3, we can see that there is a significant improvement, overall balanced improvement while using the carbon black silica dual phase filler with respect to carbon black and carbon black silica blend. These are the references which I have taken during this research work. These are the publications which has been published so far. Thank you.
So thank you, Pankaj, and you have finished early. You should get an appreciation award for this because we have some time lag. The stage is open now. If anybody has any questions, you can ask Pankaj. Yeah?
Yes.
Yeah.
Can you explain something about graphene? People are talking about graphene for the last many years, but what actually happens during aluminum? Anybody using it because the cost is very high?
See, for
What
the
is the purpose of graphene and can it be implemented in factories? I'm
So-
not talking about tire industries. I think almost
So-
everybody is.
basically
They are not from tire industry.
right. So even I am not from the tire industry. So basically the challenge with the graphene is that the dispersion and getting the results on the production scale. So since last 10 years, I have got many samples from many manufacturers for the graphene, and so far I have not able to get the results in production scale. So that is the challenge, and so in that case you can go for the graphene oxide, either direct you can go for the graphene oxide. Because of the structure of graphene oxide, it will have a better interaction with the graphene and polymer. In another way, the same research work which I am doing, so I am trying to functionalize the graphene with the alkylation and oxidation. So because of that alkylation and oxidation, the the graphene and polymer interaction will improve and we will be able to disperse. The main challenge of graphene is that it's a 2D structure. What is the carbon black? It's the layer of graphene. Nothing else actually. The carbon black is the layers of graphene, but it has that 3D structure. There is a agglomerate. So because of that agglomerate and structure, it is easily mixed with the rubber and give a good filler and rubber interaction. So that is the.
People are, they keep talking about graphene, but nobody is getting implemented it.
So that
The high cost and all that. What is the
cost is not challenge.
Let me complete. Lot of R&D is being done in India also. Lot of universities are working. Lot of people around in the world, they are all working. But nobody can use it because 5 grams of material will be 50 lakhs.
See, it's not about the cost of the graphene is so far as per knowledge 60,000 rupees, 60,000 rupees per kg. But by adding graphene,
I'm taking your question. I'm taking your question first. See, no doubt cost is a big factor. Second part is that even say 5-6 years before also, there are graphene manufacturer all abroad. So yes, what he told, dispersion is one issue, and cost is major issue. And I have a presentations during post-lunch, pre-lunch session, just pre-lunch session. That is something I will cover on graphene also. Okay, we can even discuss up during post-lunch, no problem. Okay. But yes, cost is a big issue. Cost is a big issue.
You are mainly focused on tire industry. Hello, myself Navneet, representing Rocks International. मैं आज हिंदी में बोलता हूँ क्योंकि कल मेरे से बोला गया था कि आप इंग्लिश में बोल रहे हो और जिन्होंने कहा था इत्तेफाक से वो आज आए भी नहीं है अभी आने वाले हैं खैर आपका जो टॉपिक था ज़्यादातर आपने टायर इंडस्ट्री के ऊपर फोकस रखा था व्हाट अबाउट मतलब रबड़ पार्ट से रिलेटेड क्या है फॉर एग्जांपल लेट मी कंप्लीट हम लोग ओरिंग्स काफ़ी ज़्यादा में बना रहे हैं और हमारी ओरिंग्स की हार्डनेस जो है 100 शोर ए तक जाती है तो उस केस में कार्बन सिलिका कम्बिनेशन फिलर किस तरीके से काम कर रहा है क्या रिजल्ट्स मिलेंगे क्योंकि अगर हम एक और इसके अंदर प्रॉब्लम आती है अगर 100 PHR वो 100 हार्डनेस पे लेके जाते हैं तो कंपाउंड जो है थोड़ा सा रिजिड हो जाता है तो उसको जो है इलास्टिसिटी पूरी बनी रहे तो इसमें 100 भी हार्डनेस चाहिए तो कार्बन सिलिका फिलर कंबाइंड जो आप बात कर रहे हैं वो कैसे उसको फोकस कर पाए
see, basically, first of, it's not about the tire, it's about the technology and use of the instruments which we have been in the rubber industry and concept and ideas. So how we can measure, how can we understand the filler and polymer behavior, their interaction, and how we can analyze that. It can be in any industry, like in conveyor belt. Same like a tire, in conveyor belt there is a concept of low rolling resistance because it's running over the pulleys. And again there is a loss. So that comes from the power. So for the pipe conveyor belt, there are 6 ricks are there. So for that, we have to use, for bottom compound, we have to use the carbon, we have to use the low rolling resistance compound. So that is the one aspect, usage. Secondly, come to the question, each and every formulation designed on the basis of total need and application of the product. It's very difficult to answer you directly, but after this session, we can sit and we can discuss.
Okay, thank you.
Yeah, I'm Amarpreet Singh. Hello. Yeah. So first of all, very good presentation. But I know your presentation was mainly focused on tire. But since you are from conveyor belt industry, so do you see any application of silica in conveyor belt industry, and are you planning to use silica in some of your products? If yes, then what type of applications?
We are using a lot of silica in conveyor belt. There is one challenge. The carbon black is a part produced from the petroleum product. So there is one requirement in conveyor belt is the fire resistance. So if I increase the dose of carbon black, by the same time I am increasing the flammability behavior of my product. And this requirement for fire resistance is very, very crucial for the underground mines belting. And each and every country has a very strong policy and strong test conditions. In that case, if I increase the dose of silica, that tendency of the behavior and the probability with the increase of carbon black to the flammable material is reduced. It's the one aspect. Beside of conveyor belt, we are making a lot of lining product for the mining and rubber industry and the lining applications, and many accessories for the rubber industry also. In that case, we are using silica because we produce a non-black seats. Especially in European country, they have a color coding. They need yellow, green, dark green, white. So we can't use carbon black there. So we are using silica only for that kind of application. And last, for the food grade application, customer want non-black conveyor belt. We are producing a food grade conveyor belt also. In that case, we are using silica only. Basically, it's blend natural rubber and SBR, and sometimes natural rubber, SBR, and PBR, all three, depend on the required properties. We are making a very unique belt. It's called a safe belt. So, in that belt, like a tire or other things, there is one triangle inside. It's not run over the pulleys. So, for that triangle, we need to maintain the very low rebound resilience, very low heat build-up, and again should be a non-black. So in that case, we are using silica with the coupling agent to get maintain all these three properties.
So there also this silica will be helpful. I'm Shambhu Agarwal from Relaxo.
Yeah, we have a tie-up with the CDI, and we are doing the regular basis the testing, the required parameter to meet the low rolling resistance conveyor belt.
RF. So there also silica or CSDPF, this filler can be used. I have one question for you. You have mentioned this 4 PHR of silane, silane for this dual phase filler. Like silica alone, we are using 8% of TESPD, okay? So here also some percentage you have tried, or just 4 PHR is fixed for all the dosage level?
When I started that first session, the first chapter, in that time we have taken on the basis of that percentage.
Yeah, correct.
Diet percentage.
I'm asking was second phase, your second study basically.
So in second study, then again we need to, because for the silica, it has been optimized on the basis of trial.
Yeah.
But carbon silica dual phase is slightly different with the silica and carbon mix. So in that case, we need to analyze we need to optimize that TSPT doses.
Correct.
So that's why then we have done again run the trials to optimize that doses.
Correct.
So on the basis of study, we have found that the 4 PHR is giving the better results.
Yeah, thank you. Thank you.
Can you ask your question after this session? Yeah. Okay. Thank you. Thank you, Pankaj, for your nice presentations and defending
Thank you, sir.
questions.
So please stay back. And may I request our session chairperson, Dr. Amit Chakrabarti, to present a memento to our speaker, Mr. Pankaj Rai. Can we all have a big round of applause, everyone? Thank you very much. Dr. Amit, please continue.
So the second speaker of this particular session is Mr. Pradeep Roy. Pradeep is currently working as a senior sales manager in Cabot Corporation in the vertical of, I think, reinforcement materials. And he has his technology degree from University of Calcutta in I think, polymer science and technology. And his work is not only Cabot. Before that, he worked in some tire manufacturing company, raw materials supplying, and some petroleum industries also, right? His areas of work is around R&D, sales, technical services, procurement area, and overall working experience of around 15 years. And he has around 2-3 technical papers also in different journals. So let us welcome Pradeep for his next speech. And his speech is mainly for the people and for the planet. He will talk more about the sustainability possibly. Okay? Okay,
Yes,
you
right,
please
sir.
continue.
Yeah, good morning, everyone. I think, first of all, I would like to thank you, the organizing committee, Sarin sir, for arranging this wonderful event and inviting us to participate in this. So I think Pankaj ji has given us a wonderful start of the session with some interesting topic like carbon silica dual phase filler. So just want to, before going into my deck, just want to mention that Cabot was evaluating this technology, I think 15, 20 years back. And now we have gone further ahead and have come up with some latest technology solutions which are different from this one. And maybe I would like to touch upon at the end of my deck. So I think for past 4 or 5 years, we have seen intensive focus on sustainability front from both external stakeholders like customers, communities, and also internally we are focusing on developing some products or technology solution that will help us achieve our sustainability goal. And earlier in 2022, we have announced our net zero ambition. So now I would like to take you through our today's topic, so evolving path to advancing sustainable reinforcing carbons. So mostly for the rubber industries. So I think most of all you know about Cabot. So we are a leading specialty chemicals and performance materials company. We are 140 years old company, founded in 1882. Our headquarters is in Boston, US. We have 37 plants spread across 20 plus countries. As per FY23 sales, we are $3.9 billion company with a manpower force of 4,000 plus. Regarding business verticals, we have 2 business verticals. One is reinforcement materials, where I belong. So reinforcement materials consist of products that caters to the tire and rubber industry. And performance chemical segment is products for all the non-rubber application like ink, paints, pigments, coating, plastic master batches, and so on. And I think for decades, we have been holding this number 1 or number 2 positions globally in these 2 business verticals. So here I would like to highlight on our purpose, that is creating materials that improve daily life and enable a more sustainable future. So we generally fulfill our purpose by focusing on 3 pillars. One is driving material innovation. That means we create materials that will deliver next level performance and reliability. And second pillar is partnering with our customers. So we collaborate with customers to develop solutions that will give them competitive advantage. And lastly, create materials for our future. So our strategy is always creating for tomorrow, grow, innovate, optimize, obviously by collaborating with our customers. And we have broad portfolio of solutions and technical expertise that enable application innovation. Now in today's topic, sustainability. So if we look back into our history, sustainability is not a new thing for Cabot, and we always been a leader in sustainability in terms of measurement, on reporting. So long back in 1950s, we have started employee health study at carbon black facilities. Then in 1980s, we have launched our internal Cabot Awards for Excellence in Innovation. Then in 2005, our Tianjin site in China opened with SOx removal technology, and we have also launched Drive to Zero SH&E management. Then in 2010, we have joined CDP Disclosure Insight Action and first responsible care certified site in China. So it's a long journey. So just to summary, in 2022, we have announced our net zero ambition to achieve net zero emission by 2050, and now we are working on to building up these interim goals to achieve this net zero ambition. Now here I would like to highlight on some of the awards and recognition that we have received on the sustainability front. So Cabot is named one of America's most responsible companies in 2024 by Newsweek magazine. So this is the 5th consecutive year we have received this award. We have achieved platinum rating for sustainability from EcoVadis for 4th consecutive year, and platinum is the highest level of recognition that is available at this platform. So Cabot ranked among the top 1% of all companies evaluated. Then our composite solution, which is our patented liquid mixing technology and composite product, the C2C DX9660, we won Chemicals and Compounding Innovation of the Year award that we received earlier this year in the Tire Tech International Expo in Hanover. And finally, the same solution, E2C solutions, named to European Rubber Journal's top 10 elastomer for sustainability list in 2020, 2022, and 2023. And last but not the least, our today's topic, our recently launched Evolve, which we launched actually last year. This was also named top 10 elastomers for sustainability list in 23 and 24. So now if we look into today's industry or the products that we use in our daily life, like polymers, rubbers, plastic, chemicals, that comes from this refineries and petrochemical industry. And by the process of producing these products, they also generate a lot of byproducts. So these byproducts that can be used as feedstock to create valuable products like carbon black, then tire or non-tire applications. Or these byproducts can be used, or it goes in the energy production as a fuel, which releases carbon as carbon dioxide. So what we do, we generally actually convert this, what is happening? One second. Yeah, so what we do generally, we convert this byproduct into highly engineered reinforcing carbons. And from that carbon, actually, we produce this tire, and maybe something is happening wrong here. So what we do, that from this byproduct, we are actually converting it to engineered product like carbon black. And by this manufacturing process, we are able to capture up to 75% of the carbon from this feedstock. And in this process, actually, we also produce some energy, like tail gas and electricity, that is delivered back to the industry. So that's why we are promoting this circularity. So this, if we consider from 2005 baseline, earlier it was 12% reduction, but we are committed to reduce our CO2 gas intensity emission by another 5% by 2025. So, but what we have achieved, the 75% capture of the carbons from the feedstock, or this another 5% reduction in the CO2 emission, this is not going to be enough considering our sustainability goals or to our duty towards our planet. So that's why we have announced our this net zero ambition, that we will achieve net zero carbon emission by 2050. So now I would like to take you through a very short glance to our transparency and our pathway to this net zero ambition and what would be our approach. So transparency means transparency of reporting and disclosures that are aligned with recognized framework like carbon disclosure projects like CDP or Global Reporting Initiative, GRI, then Task Force on Climate-Related Financial Disclosure and SASB. So we are very much transparent on what we are achieving in the percentage, and all these are published. Then our pathway, we continue to make progress on our 2025 sustainability goals, and in this process, we are developing interim targets to achieve net zero ambition by 2050. So one of the interim targets in the category of product sustainability is that whatever new products or new process technology development that will come up by 2025 will have a sustainable benefit. Then so what would be our approach? The approach would be we drive yield improvements and CO2 reduction programs, invest in waste heat recovery, improve energy efficiency, and increase the use of renewable energy like solar power. We increase circularity in our operation. So we strive to achieve net zero in 2050 through collaboration, innovation, and government policy. So now if we look at the today's challenge in a commercially available sustainable products, this challenge are threefold. So maybe we can have some material with sustainable content, but it may not give you reliable performance. Or you can have some material with sustainable content, and also it is giving reliable performance, but it may not have the scalable economics. So we are working on all these three aspects of this challenge. So we are developing industrial scaled solutions that will address this challenge. So when we are actually evaluating all these challenges and our way towards this achieving these sustainable goals, so we understand that there is an intense need to come up with our own brand of products that will align with the sustainability goal. And these products, and ideally speaking, this should not be a single product. It should be a brand or a technology platform where a lot of products or technology will evolve in the coming days, and we'll keep on launching the products as per the market needs. So there we have launched actually our Evolve Sustainable Solutions last year. So now I will take you through a 2-minute short video. Yeah, sir, maybe after this day, sir, maybe, definitely, sir, after the deck, I will take up your question. Yeah. Yeah.
To thrive in a changing world, we must all evolve. We must improve, grow, and adapt. At Cabot, we are constantly evolving, looking for new ways to create materials that improve daily life and enable a more sustainable future. That's what our Evolve Sustainable Solutions technology platform is all about. Products powered by Evolve Sustainable Solutions are designed to deliver sustainable content with reliable performance at industrial scale. The Evolve Sustainable Solutions technology platform provides a path to producing reinforcing carbons in 3 ways. Recovered, delivering reinforcing carbons from circular value chains using materials recovered from end-of-life tires, such as products made with reclaimed carbon and from tire pyrolysis oil. Renewable, reinforcing carbons made from renewable materials, such as products made with bio-based particles and from bio-based feedstocks. Reduced, materials made with a reduced greenhouse gas footprint through the implementation of industrial decarbonization technologies using processes like carbon capture and sequestration. Our Evolve Sustainable Solutions program represents a significant portion of Cabot's R&D spend, with the goal that 100% of our product and process development projects will have a sustainability benefit by 2025. Evolve is one more way Cabot is a leader in performance and sustainability, guiding us forward toward a better tomorrow. To thrive.
Okay, so what we have seen there, so Evolve Sustainable Solutions is a technology platform for delivering more sustainable reinforcing carbon. So it's a technology platform by where a lot of products and different technologies and different verticals is going to come out. So here are the top 3 pillars that we are considering under this platform. First one is recovered. So recovered pillar talks about the materials that will come up from the circularity, like end-of-life tire or tire pyrolysis oil or reclaimed carbon. Then second pillar, renewable. So as the name suggests, it talks about the materials that will come out from these renewable sources like bio-based feedstock. And last one, that is the reduced pillar. So it is also a very important part of our sustainable journey. So reduced pillar talks about the materials that will be developed with significantly low GHG footprints. So products powered by Evolved Sustainable Solutions win our sustainable content with reliable performance and industrial scale. So this reliable performance at industrial scale is very important. As Cabot, we are a 140 years old company, and we pride in our legacy. Customers known us for our product performance and reliability and quality. So on these 2 fronts, this reliability performance at industrial scale, we are not going to compromise on these sustainable products also. So now if we look at our recovered pillar, so this is a simple schematic diagram just to show you how we are introducing circularity in our process. So here I think you all guys now know this diagram. So because from the end of the life tire or used tire, it is pyrolysis is being done. So after pyrolysis, we get either reclaimed carbon also generated, and also this tire pyrolysis oil is also generated. So from this tire pyrolysis oil, what we do, we take into our carbon black production as a feedstock, along with our regular feedstock and produce a carbon black with some sustainable content. Or also, we can use reclaimed carbon and take it into our carbon black production and coming out with some carbon black with containing some sustainable carbon black content. So under this recovered pillar, what we discussed, we have shown in our previous slides. So we have launched two types of commercial grade of products. So first one is the tire pyrolysis oil-based circular reinforcing carbon. So these are made from the TPO, tire pyrolysis oil, as feedstock. So these are powered by Evolve Sustainable Solution. It comes with a ISCC Plus certification, 100% sustainable. These products are drop-in products, so it will give you exactly same performance as the virgin carbon blacks, regular grades, just exactly equivalent. And we have full range of reinforcing, semi-reinforcing, ultra-reinforcing carbon black, starting from 100 series, 200, 300, 500, 600 we can produce. So globally we have 5 carbon black sites till now, those are ISCC Plus certified. So we can supply depending on the customer demand from any of these plants. We are also in the process of getting ISCC Plus certification in our Asian plant, like in Indonesia or in China. So here, just want to give you a brief about this 100% sustainable product that is mass balance based. So here we are using TPO and mix it with our regular feedstock, and then we take a mass balance approach, and whatever the carbon black that comes out from that reactor, that we consider that percentage on the mass balance approach as 100% sustainable. Like if you use 100 metric ton of TPO as a feedstock along with a regular feedstock, and reactor conversion rate is 60%. So whatever 60 metric ton of carbon black that comes out from the reactor, we can certify it as 100% sustainable. Now coming to the second product, so it's a different category of product. This is reclaimed carbon-based circular reinforcing carbon. So again, this is powered by Evolve Sustainable Solution. It also comes with ISCC Plus certification, but with 10% sustainable content. Here we are mixing 10% of reclaimed carbon into our virgin black in our process. So generally we know this dispersion of recovered or reclaimed carbon in the virgin black in the process is very difficult. So you can see here the physical blends. If the dispersion is very poor, and during transit or your storage condition, it actually these two grades phase separates. So there is non-uniformity throughout the product. But by this, our novel mixing and pelletization technology for better dispersion, we can achieve much better dispersion, what you can see here. So this product is not a isoanalytical on molecular level like the first one with the virgin blacks, but still in some used cases and in some products, we have seen equivalent performance in rubber application. So this 10% sustainable product that we have launched right now for semi-reinforcing grade, like in N550 and N660. So, and we are seeing some good interest globally, also from India, regarding these two series of products. Now coming to the renewable pillar. So in renewable, this will include products made of bio-based feedstocks or other renewable reinforcing agents. So we are actively working with some alpha customers to develop commercial solutions on industrial scale. And under reduced pillar, so as I mentioned earlier, that products made via carbon capture technology with demonstrably lower scope 1 and scope 2 GHG footprint. So here the intention is to capture as much as carbon possible from the feedstock by some breakthrough technologies or carbon capture technologies like this. On this reduced pillar also, we are working with some of the customers and partners, and in the process of development of commercial scale, maybe within the very near future, we'll launch some products under this category. Okay. So this, till now, what I have discussed, that was our Evolve products, mainly targeting to the sustainability of the industry, the need of sustainability in the industry. So, but as you all know, sustainability comes out with reliable performance, quality consistency, what we are maintaining for years. And from Cabot, we have all sorts of carbon black grades, like ASTM grades. But other than ASTM grades, we have close to 200 grades, which with tuned morphology or practically engineered carbon. So here I would like to just touch upon a few of the categories of products that we are having. I think first one is the unique morphologies to enhance durability. So here actually we have changed the morphologies. We have just tuned the structure and surface area from the ASTM series as per the customer need. Because some of the application has some special needs which cannot be made by the regular ASTM grades. So these products can help our customers to achieve those goals. Okay, thank you. So this Ferron series and Endure series, I think the application areas are injection molding, anti-vibration, conveyor belting, midliner, and people in India are using it to achieve some higher performance. And then coming to the low impurities or grit to reduce surface defects, I think yesterday Mr. Ghosh from one of our competitor has shown in a presentation, mentioned this series of products as the benchmark to the industry. So thank you for that. So this low impurities product like Spheron SO, Spheron 6000, Spheron 5000A. So these are very low grit products, even with zero grit, for smooth surface, for very good extruded products. And the third one, that is low pH, that is low polyaromatic hydrocarbon to meet regulatory guidelines. That these products are targeted for the food contact or skin contact applications. So what we do, we generally measure pH content of each and every batch of these products and mention the pH content as per the customer's regulation requirement in our COA with a certificate. Then coming to the engineered elastomer composite, I think Sir was telling when Mr. Pankaj is giving the presentation about this graphene and all, and I think Pankaj was mentioning about carbon silica dual phase filler. So as I mentioned, we have come a long way. So these are the engineered elastomer composite what we have developed over the years. So it's a Cabot patented liquid mixed product where we can disperse any reinforcing filler in rubber matrix. So these products are mainly for the niche application for the tire or conveyor or mill liner applications where customer needs a step change performance in terms of mileage, rolling resistance or higher performance, higher durability. So these are the few launched products. And lastly, the Evolve Sustainable Solution that we have already discussed. So we understand the challenges faced by our customers. We are actively working in to find innovative solutions that deliver sustainability benefits, and we work together to define and create sustainable and scalable solutions. So I think that was our deck, but just to mention, on this sustainable front, we are also working on a lot of projects internally in the development under reduced pillar. We are working with upgradation of the recovered carbon and reclaimed carbon of all these things. And these projects we are doing with some of the key partners in India as well as outside. So if any one of you are interested to collaborate, you may contact us. So I think, or you can connect with our distributors. For North India, we have JMF Synthetics, Bombay Chemicals, and for West and South, we have Rishirup. So thank you so much.
Thank you, Pradeep, for briefing the need of sustainability, and he has actually covered the different ways of achieving the sustainability, practically keeping in mind the carbon black industries.
Right.
He covered it, and according to your definition, if you think in a very simple way, don't go for the definition, concept. Any process, any product which is available or we are making, how we can make it less health sensitive for the people and for the planet. That's the general definition, and the sustainability as such is different. The concept is same, but the approach is different for different industries. The different methodology which will be followed for the carbon black industries or for the silicon industries or for a company which is making toluene will be different. So he covered, and if you can talk a little more also with that. Yeah, sure.
See, carbon black is the thing which pollutes the complete environment. Do you agree with that?
No, I don't agree with you. I don't agree with you in one sense. There is a continuous process of improvement for that. And I can tell you that even, I am also from the carbon black industry, I can tell you if you go with your white shirt inside the plant, you will come out with a white shirt only.
How come?
Yeah. Sure. No problem. No problem. Pankaj can. I am giving the answer for your sustainability question. Sustainability question, you asked the definition. So definition is that which is create any process or any product which is reducing the health risk, pollution and others, but it is different for the different industries. It will be different. One carbon black company will be different, and he will give the answer according to you.
So,
Pankaj,
just to,
Pankaj, you will be getting extra time, which Amit ji has taken.
Sure, no problem.
Yeah, so I would just like to brief that from a carbon black industry, that what we have shown in this. So we are working on 3 pillars. So one is the circularity. So where carbon black generated from this circular products like end of life tire pyrolysis, oil from there. And number 2 is your reduced. So where we are developing in some technologies or some products which will give you very low GHG emission. So maybe here our intent is to improve our yield also, by which you can capture as much as carbon as possible from the feedstock. Okay, and convert into products, making to carbon black. This carbon black again goes into products, so it's maintaining the circularity again. And one is the renewable. So we are also working in very advanced stages to develop carbon black from this bio-based feedstock, bio-based things. So this is not a single thing, and a lot of work is going on, different fonts, different technologies will come out. So maybe we are just in the beginning of this new technology. So in the coming days, we'll come up with a new one. Sir, we have different products for that. Yes, we can. And we have, that's why coming up with this liquid mixing technology, our composite material, E2C, where you no need to mix carbon black into a product, into your plant. We will give you a ready-made product, which comes with a natural carbon black mix with your much higher dispersion, with your step change, you will get step change performance in your product, in your tires.
Hi, Mr. Roy.
Yeah. Good morning.
See, it was very interesting, presentation. But it would have been better if you could convince us from cost effect, why should we use sustainable carbon black over regular composite? Suppose I'm from a non-tire industry. We are using N660, semi-reinforcing filler, right? Why should we go for your Cabot sustainable filler? With reference to cost, if you could have told it, no? We could have been better convinced. Why should you go for that? That portion is, I think, missing.
Yeah.
Can you just put something?
Yeah, definitely. So here, see, the sustainability. So I think now this is a buzzword. So every industry is coming up with this thing. And obviously, this sustainability is also a really very genuine thing, what we need to work on for our future generation. So if you or your industry or the government here or the local authorities, they do not have such guidelines, then I think then you do not have any compulsion to use these products into your production. Because these products we are launching, or not only us, or anyone is launching right now, the economics of scalability is still not there. So whenever a new technology comes, new product comes, it has to be a much more bigger this market base or the product demands. So once you can find, or once we can achieve the economic of scalability, then you will find your normal N660 and our 660, this sustainable black, we'll have a very
that we understand. But the thing is, there is an effort from all sectors to reduce pollution. Okay, there is a pressure on all industries. But in our industries also, management wants cost cutting in every aspect. Okay, so if we have to take that sustainable filler in place of their normal 660 to minimize the effect of pollution on the environment, we have to convince the management also, and that endeavor should be also there from your industries. How you can push this product into all the industries, that effort should be there, no?
So, sir, I can just respond to in a different manner.
Yeah.
So, sustainability means not only you need to use this sustainable black. Sustainability means you can increase your product life. That also give you a sustainable benefit. Or you can increase the performance of your product. So, we have some of the solutions in our product umbrella that we can maybe later connect and discuss.
Okay.
That will also give you a sustainable benefit. So sustainability comes from different angles. It is not only you have one vertical with the sustainable products and all. Yeah.
Okay,
Yeah.
thank you. Thank you.
I do not know whether they can share here.
Yeah.
Sorry. Yes, tell me, sir.
Right, thank you. Yeah, so here it shows that physical blend, the first structure, that white and black one, there's a compatibility issues, and next one, there's the Starling CO RC110. So it is a compatible. So as far as we understand, the reinforcing phenomena in the carbon black takes place on the surface. Okay. But I don't know whether this is a particle structure you are showing, but here that sustainable carbon that is encapsulated, so it is not getting that surface. So how you claim that it will give the similar reinforcing properties?
Okay, so this is just a schematic representative photo.
Okay, it's
So
not
here-
a particulate
Yeah,
structure.
here what we are doing, we want to show that the 10% sustainable black is equally blended in the pellets of carbon black.
Okay,
Yeah,
Pallets.
that's the
Okay,
representative
thank you.
picture.
Okay, thank you.
So as I mentioned, so you have come up with this question, thank you. So this first category, it's a 100% sustainable material, so it's a equivalent drop-in product, exactly same properties, exactly same like regular grades like 330, 550. And this one is the 10%, this one is not isoanalytical on molecular level with the normal carbon black. There may be some percentage of variation in some properties, so you need to test the samples as per your application. But this one, no need to test. You just use it as regular grades.
Okay,
Thank you.
So, thank you, Pradeep. Yeah, if there is no questions, we are concluding this session here, okay? Thank you again, and
Thank you, sir. May I request the session chairperson, Dr. Amit Chakrabarti, to present a memento to our speaker, Mr. Pradeep Roy. Let's all put our hands together for this wonderful session. Thank you very much. Now may I request Shri Saurabh Malhotra, convener NRC 2024, to felicitate our session chairperson with a memento. Shri Saurabh Malhotra. Thank you, Dr. Amit Chakrabarti. Thank you very much. Now, ladies and gentlemen, it's time for a short tea break, 10 minutes tea break, and we be back for yet another technical session number 5. So request everybody be back on time in 10 minutes. See you all. Requesting everybody, please come and take your seats. Requesting everyone to kindly be seated for yet another technical session. Last 1 minute. Everyone, kindly take your seats. We are just about to start. Last 30 seconds and then we are going to start with technical session number 5. Recharged after the tea break. Now is the time for us to begin the technical session number 5. Now, before I invite the session chairperson, Dr. Shailendra S. Solanki, to come and preside over the session, I would like to introduce him a little. Dr. Shailendra S. Solanki is a polymer chemist and specialized in rubber chemistry. He is responsible for rubber compounds development, material qualification, and product validation. He joined Imperial Auto since August 2013. Presently, he is working as Head R&D and Head Manufacturing Engineering ME for Rubber Division at IAIR&D Center at Faridabad, Haryana, India. IAIR&D Center is the state-of-the-art R&D for materials development, product validation, engineering design, and application development. Dr. Solanki has a proven track record of driving company growth by developing innovative product solutions to understand customer unmet needs to offer right product and improve quality of products for our customers globally. Expertise in specialty polymers for fluid transmission system products, managing and implementing plans towards new solutions, validation and services as per regulatory guidelines, successfully managed multiple R&D projects entailing new product development and troubleshooting. Dr. Solanki has 23 years of experience, including 5.5 years in PhD in basic research, product R&D, rubbers and material science, both in industry and in academia. Dr. Solanki, Senior Research Fellow from CSIR. He was awarded the PhD Polymer Chemistry from National Chemical Laboratory in 2003. After PhD, he got R&D training on fluoroelastometer at DuPont, Shanghai, China in April 2007 with excellent award. Also secured top 10%. So can we all put our hands together for our session chairperson, Dr. Shailendra S. Solanki. So please preside over the session.
Thank you. Hello, good afternoon. So today, our first speaker will be Dr. Anshu Ghoshal. Please give a big applause to her. A brief introduction. Dr. Anshu is the Director Technical at Singh Plasticizers and Resins India Private Limited. She holds a PhD in Chemical Engineering from the University of Texas at Austin and B in Chemical Engineering from IIT Roorkee. With a distinguished career spanning roles at GE Plastics from Vernon, USA, Dr. Ghoshal brings extensive expertise in the field of chemical engineering and polymer science. She is a member of IRI, ACS, and has 10 peer-reviewed papers. Dr. Ghoshal's contribution have been recognized with 3 awards from 3 US patents, and she has received the prestigious Woman of the Year award from Time Tire and Rubber Industry Leadership Acknowledgement TRILA Awards. So we welcome her. Please give a big applause. Madam, please.
thank you for the warm introduction. I'd like to thank the organizers for a very well conducted and well organized conference here. Today I'll be talking about sustainability, and we are all familiar with the concept of sustainability, but our focus has been largely towards defining it and figuring out how to convert it to products that can actually be used in the industry on the ground, and how to make it into a practice in our operations. Okay, a brief word about my company. Zinc Plasticizers and Resins. We are leading manufacturers of PowerPlast brand resins. Our expertise is largely in phenolic resins and dry bonding resins, resorcinol formaldehyde resins, focused towards the tire as well as non-tire industry. Our products are approved by global manufacturing giants, both in tires and conveyor belts and other auto components. All of these products, being very critical to the quality of the finished product, have to undergo very stringent tests and evaluations at the customer's end. We are a preferred supplier for tire grade resins to some global tire manufacturing giants, and about 35 to 50% of our business is through exports. We are a Government of India recognized export house and a winner of the national award a few years, about 10 years ago now, in the MSME industry sector. Manufacturing, we have a manufacturing plant in the NCR region, 6 manufacturing lines, flexible plant where we can give you materials in pastiles. Pointer nahi hai, pointer nahi hai. Okay. So we can discharge material in pastiles, flakes, liquids, or powder form. The manufacturing plant and the products are all compliant with REACH guidelines and ROHS guidelines, which we do test for and verify periodically. Product families, more or less the important ones I'll list here. Dry bonding agents, several of you, we have been fortunate enough to supply to some of you. Resorcinol formaldehyde resins, we were one of the first producers of this product in India. Environmentally friendly resins is the product line that we are trying to grow. We've added some materials to that, commercialized them, and now looking to add some more as we go along. Alkyl phenol tackifier resins, these are again supplying to quite a few of the industry here. Phenolic resins for reinforcing, and HMMM HMT, which is used in combination with the dry bonding, resorcinol formaldehyde, and the environmentally friendly resins. So when we start looking towards sustainability, it's all become about greenhouse gas emissions, and it's not just a product or a step in isolation. So sustainability has to be looked at through the entire life cycle of the from the sourcing to the manufacturing to the supply, distribution, storage, the product use, so our customers' product use, and their end of life cycle products. And only then, when you cover all of these bases and you make sure that there is sustainability being practiced at each of these stages, that's when you come up with a good sustainable product and a sustainable practice. Okay. So UN came up with these 17 sustainable development goals, and they were all very high level, and at first glance they were very not as easy to understand, even though they were very, intuitive. All of us knew that these are all good things to do, but it was not very clear about how we could incorporate that in our practice, okay? So just from our discussions, deliberations with customers, suppliers, and various stakeholders, we came up with, we narrowed it down to about 4 of these, which are, which help us. If we practice these as an industry, it helps us promote sustainability in keeping in line with these UN sustainability goals. And these were all, the first one was non-petroleum based feedstock. That's of course easy to understand, a lot of focus on that currently in the industry. Reducing energy and energy consumption and water usage. Number 3 was minimizing waste and pollution. And then of course moving towards a circular economy. Some very good papers we heard on that just prior to this one. Before this, before we get into dive down into all of them, sustainability initiatives that we have been taking as a company for many years now. Our plant and energy requirements, we were switched to natural gas for low emissions. And now further, I think there's a focus on moving to renewable energy sources, although the jury is still out about which form of energy is going to be the most sustainable. And we continue to explore that going forward. Having the ability to do a zero liquid discharge facility with 100% recycle of all wastewater. We have the ability, we have developed the infrastructure to do that. Solar electricity generation added about 10 to 20% of our current energy requirements are being covered by solar electricity. Rainwater harvesting, very important in the NCR region. For all of these efforts, we got ISO 14001, 45001, and 50001 certifications. We moved to packaging material made from 100% renewable waste and pulp, paper pulp. Raw materials from bio-based sources, which is going to be ongoing focus for the company. And reduce transport costs with local RM supply, okay? Now this, this is something that has been going on for various, under various buzzwords. It was indigenization, exports, import substitution, and all of that. But it's really the sustainable things to do. We did a calculation once when we got into the whole GHG emission calculations, that importing about 1,000 metric ton of raw materials from Japan to Mumbai seaport versus indigenizing it, we save about 100 tons of carbon dioxide emissions per year. Okay, so it's not a trivial number. It is something that all of us have been doing, but it does add to the sustainability goals as well. Okay, so taking the first one, non-petroleum based feedstock. Firstly, why? Yeah, sustainability is a good thing. We have found that most of the time when we are dealing with sustainable materials or non-petroleum based feedstock, they add to the health and safety of the manufacturer, the user, and the person who's using the end product. Okay? And in many cases, they actually not only add to sustainability, health and safety, cost, and also give you property enhancements. Now in our industry, using bio-based feedstock was not new. Some commonly used plant-based feedstocks that are accepted in the rubber processing industry are cashew nut shell oil, tall oil rosins, terpenes, and rosins. Okay? Other raw materials that we are looking at now from sustainable sources are lignin, lignin-derived phenol, tannin, tannin-derived phenol, hydroxy HMF, and glyoxal. And as the industry matures, we have been needing help from our associates in academia, because some of these developments are still in the early stages of technology development. Sustainable resins that we have talked about some of these earlier, the ones that we offer. Today I'll talk a little bit about each of these. A green, a tackifier resin. This is our new launched product, which goes up to a biorenewable content of up to 70%. Okay, so we had been making products and had offered them which were up to 50% of biorenewable content. Now we are trying to take it forward, moving it from 50 to 100% biorenewable content where possible. Then 1872, 1963 adhesion promoters, which replace harmful chemicals like resorcinol and also have about 20 to 25% biorenewable content in them. Reinforcing resins, these have various 10 to 40% of about biorenewable content. And as you can see, all of them add in some way or the other, they add to the property, they bring some benefit to the property table that we offer, that these resins offer to the rubber compound. Cashew oil and tall oil based resins, they have been replacing petroleum based feedstock for a long time. These are all sustainable bio-based raw materials. These are industry accepted materials. Property enhancements they offer are abrasion and tear resistance, high modulus, high resilience, lower compound viscosity during mixing, chemical and water resistance, and fire resistance. Now, these find use right from tire manufacturing to all kinds of auto components, friction products, nitrile-based adhesive cements. So, very widely used products across the industry. So, would just like to talk about this new grade that we have, GTR 1506, the one that is using about 70 to 80% sustainable raw material content. And we have some preliminary results here today, but as we go forward, we'll be doing extensive testing on them, and we'll be sharing those results with all of you in subsequent forums. Color and form available as pastiles, as you are all used to seeing from zinc plasticizers. Softening point, again, in similar range to other tackifier products that are out there. Acid value, 20 to 40. Ash content, controlled and soluble in common solvents. So basically showing you that all of these products are comparable to, in properties, to products that you see from normal petroleum-based feedstock materials and what are the industry standard tackifier resins currently. So this is data from NR compound with a moderate to high filler loading. The control is the industry standard PF resin tackifier that is used, and the trial resin is the GTR that we are talking about. Very comparable rheological properties, physical properties, once again, very comparable physical properties, no loss of abrasion, and very superior, very much superior green tack strength. Okay, so a lot of work has gone into incorporating the bio feedstock, because anytime you're changing the raw material, you are going to affect the properties of the final product. And the consistency that you get from a petroleum-based feedstock, that's what allows us, allows the resin manufacturers to give you controlled properties and consistency over the years. Now, to get the same thing from a bio-based feedstock with variability, variable input quality, and getting over some of the, the drawbacks that these bio-based feedstock bring, that's where the technology lies. That's what we are trying to work for. that the finished product should have comparable properties in all forms and be able to give you either a cost benefit or a property benefit in addition to the sustainability benefits that we see. Now switching gears to adhesion promotion, in adhesion promotion for bonds between rubber and reinforcements like tire cords or fabrics or steel belts. Now this is the area of focus here. That's been an area of focus for our company. One of our first commercially accepted products was the adhesion promoter, the RF resins. So resorcinol has been conventionally used, still used along with silica blends or stearic acid melts, used extensively in the industry. Many companies and many applications have refused to switch from resorcinol into other products. Now it has enough drawbacks. Highly hygroscopic product, it sublimes. So at the high mixing temperatures that are seen in your compounding section, it will vaporize from the solid directly to a vapor stage, and it will cause a loss of product, as well as deposits everywhere in unwanted places. Any cool surface will start seeing these deposits. And then once it is compounded into rubber, there will always be blooming to the rubber surface, it being a small molecule. Now, over many decades, there have been improvements to this in the form of resorcinol formaldehyde resins, where the free resorcinol content was reduced, limiting its hygroscopic nature and the fuming nature, and then moving on to various modifications on the resorcinol formaldehyde. The one that's most prominent and most used in the industry is the styrene modification. This brought down the free resorcinol or the escapable resorcinol content to about 2 to 5% and made this product practically non-hygroscopic, low blooming, low fuming and non-blooming. Then we came to the free resorcinol content less than 0.1% or materials that did not have any resorcinol at all. Okay, so making them, limiting the use of this harmful chemical. And then going one step further, we have introduced these resins with sustainable raw materials as well. So these bring, like I mentioned once again, sustainability and just a standalone thing is not something that may or may not find acceptance. So they all bring some additional property or process benefits to the user industry. Okay, worker safety, material loss, limiting material loss from the fuming, mold cleanup, mold cleanup and silo maintenance that take up time because of the fuming nature of the resorcinol raw material, and then it's environmentally friendly. Okay. So we have two grades that are commercialized of this material, about 20 to 25% sustainable raw materials in these. These are novel resins, limiting the use of harmful chemicals like resorcinol. Okay. PP 1872, which is the truly resorcinol-free material. Yeah, okay. It's ideal for bonding with polyester, nylon, brass-coated steel wire, cords fabric, no fuming, weight loss, and improved mechanical properties in the rubber compound. Again, in 1963, very good bond strength, and again, improved tensile properties of the rubber compound. Some data here on the adhesion and aged adhesion of these compounds. The compound A, which is the one in the middle bar, that's the 1872, which is the resorcinol-free version, and the compound B, the third bar, that's the 1963. And here the control is pure resorcinol. Okay, so comparing that, we see matching properties of adhesion, of unaged adhesion, but then where you begin to see the benefits are in the aged adhesion. Okay, so in heat aging and humidity aging, both of these products give you improved performance over resorcinol. Dynamic properties, both of them, again, now the green bar is at 30 degrees, blue is at 70 and 100 is the yellow, and we see that consistently all of these, the dynamic modulus is higher for 1872 and the 1963 compared to the control, that's resorcinol. For the tan delta, we see lower values at the higher temperatures, indicating lower hysteresis, which is always benefit for the ply compound. Would like to, again, another aspect of sustainability is resins made with alternate raw materials to reduce the carbon footprint during sourcing and manufacturing. Okay, so PP 1827HT, this is a high performance tackifier resin, equivalent in performance to the co-resin material. Again, made with all indigenized products and giving, aged and unaged tack retention that we see, comparing very well to the co-resin compound with the curing profile. Sorry. Yeah. Previously, we had some issues with the curing, and that's the again, when we are changing raw materials, there are changes that we see. So what we try is to make them as drop-in substitutes for the user industry, so that the acceptance cycle is shortened for all of you. Okay, I think we are kind of running out of time. These products are all you have seen. So various various products, again going on the same theme, that not just bio-based feedstock. There are many other harmful chemicals that are there in the industry, and we've been trying to control them and eliminate them, making products which can be made from not any highly novel compounds that would be at 5 grams for 5,000 rupees kind of numbers, but just made from regular materials that can actually be put into practice and be offered to the industry in bulk scale at the fastest possible development time. Okay. Just summarizing, sustainability, how we look at it is introduction of the bio-based raw materials, reduced personnel exposure, replacement of regulated raw materials with relatively benign materials to control long-term exposure of people, and sustainable manufacturing practices for reduced carbon footprint. Okay. These are a list of all our materials. Other products that we make, but as we are short of time, I'd like to end my talk here. And some of our customers, we are suppliers and markets served, both as you see tire and all variety of non-tire products. Okay. That's all from my side.
Thank you, Dr. Anshu. On sustainability, she has touched quite good things. Like the perspective, it's not only whether product, its process, how we are thinking about our, different process to make it, whether we are efficient for energy saving, yes or no? So it's not only one perspective we have to see. So it's a good thing that Madam has shown like how they have taken a different perspective for synthesizing, tackifier reagents for high green strength, even by taking into the consideration of sustainability of the products. So the concepts up to the conceptualization and up to the final products. Session is open for the 2 questions, please.
Yes. Yeah. Reinforcing resins, the question was about, how much percentage of reinforcing resins can be added. Now that, sir, depends on what is the end use application and the rubber that you're using. Because you can go up to pretty high loadings. Loadings of about 10 PHR are quite common. Depending on some elastomers and resin combinations, if there is compatibility, you can go up to even 20, 30, 40 PHR loadings as well. But then the reinforcing resins will always bring in differences or changes to your physical properties. So, the addition would be limited by what's your requirement. Okay? For example, hardness. These are slightly different applications. So within reason, you can substitute, you can remove some of the carbon and replace with reinforcing resins. And it does bring you some benefit in mixing, because when you mix resins in the rubber compound, they do add to your mixing efficiency. Okay? So unlike carbon black, where then you would have to increase your loading of oil or some kind of other plasticizer, and then in the final product that would be detrimental to your final physical properties. But when you replace some amount of fillers with a reinforcing resin, obviously you cannot do that in very large parts, because those fillers are also bringing in very critical properties. So within reason, you can successfully replace some of these particle fillers with resins and get the same kind of reinforcing properties. Yeah. Yes.
माइक पहुंचाइए उन तक.
Ma'am, good afternoon.
Good afternoon.
In most of the rubber industries on date, we use RFL resins for rubberizing fabric, for improved tack and addition, bonding strength, okay?
Yeah.
In one of the grades, 1826, resorcinol free, you have mentioned. So can you just slightly enlighten how much effect that will give on tack and addition property of the rubberized fabric?
Just clarify this for me. Are you asking that why do we need any kind of adhesion promoter, because the fabric is already RFL dipped?
No, I'm not asking that.
Okay,
I'm telling you, we use RFL resins, okay?
Yeah.
Normally. And now you have come up with a grade with free resins.
Okay, I understand. How do they compare to the RF based resins?
Keeps on tack and addition.
Yeah.
Resorcinol.
Yeah. Yeah. So once again, I don't know. Can I just go back and show a couple of slides?
Okay, I think one slide is there where it's mentioned here how it is benefited.
Okay, I have only the adhesion properties here.
Yeah.
Okay, so the adhesion properties do compare. See, I'm comparing it to resorcinol here, but the resorcinol-based resins have actually, out of all of those categories, resorcinol has the best adhesion properties.
Yes.
Okay, in some ways. Its only drawback used to be some aged adhesion, and that's why I've compared it over here. So similar to that, the resorcinol formaldehyde resins have a good set of adhesion properties, and the resorcinol-free resins, the target during development was to be able to match the same adhesion properties.
Now, could it be achieved?
Yes, of course. So if you look at the unaged properties, so with the resorcinol, you have about a 489 number, and this is an average value. With 1872 in this study, you have about 483, and with 1963, you have about 498.
Comparable.
So, yeah.
Comparable.
And then, as you see with the aged adhesion also, all the three bars are matching quite well. Yeah.
Thank you.
Thank you, madam. And we should applaud her.
Thank you, ma'am. May I request the session chairperson, Dr. Shailendra S. Solanki, to please present a memento to our speaker, Dr. Anshu Ghoshal. Everyone, please put your hands together.
Maybe a last question for you from my side.
One more question.
Hi.
Yes, please.
Okay. So we are using this kind of resorcinol on all these things to increase the adhesion property. But the problem is that once we introduce this kind of things, the hysteresis loss increases. As a result of which, when a product goes in dynamic properties and induce forces from multiple directions, the total heat buildup increases. The problem is that if we increase the adhesion, then the product fails in aging. And if we don't use that, then the adhesion decreases. What can be the in-between solution?
See, this is not a new problem. This is a problem that has been, occurring with right from the very first time when resorcinol or something like that started being used. Okay, so that is why there is so much focus on the dynamic properties whenever you're trying to change from one adhesion promoter to another adhesion promoter, because there should be absolutely no, the industry has optimized for use of adhesion promoters based on resorcinol, okay? And anything you do to change that, that is one property that cannot be adversely affected. So be it tires, be it other dynamic applications like conveyor belts, one cannot afford any kind of detrimental change due to hysteresis. So, again, you're absolutely right. Whenever you're doing these adhesion promotion, the way adhesion promotion works, we can discuss that offline because that's a very detailed topic. I've presented that in the past. So that stiffness, when you increase the stiffness, the heat buildup will go up, and it is managed through other changes in the formulation. Okay. Yeah.
Thank you. So I think, can we take after this, because she is here only, and you can have a discussion during lunchtime or later on. Thank you very much.
Thank you.
So, on sustainability, we have listened how carbon footprints are going down, and everyone is attentive for this. We thank NRC to take such type of topics into consideration, because this is everyone's of interest. Now, next speaker is Mr. Mole Das. And his topic is on functionality of liquid rubbers. So I think this is going to be quite interesting topic. The reason is, any polymer which is having functionality, it increases its properties. Either functionality with hydroxy group, carboxylic group, or any other functionality, it tends to make its intention for the specific application because it is having functional group in the polymer chain. So this is, I think, one of the unique technology I can say because functionality in polymer, it's not so easy. And when we say this is functionality of liquid rubbers, liquid means this is low molecular weight, you know. So I think more focus it will be given by Mr. Moledas, and this session will be quite interesting because on application wise,
thank you.
Functionality rubbers. So I can give a brief about Mr. Moledas. Mr. Mole received his bachelor degree in polymer science and technology from University of Calcutta. He has 22 years of experience in rubber and plastic processing, quality control, and technical services. He is working with Kurare India Private Limited since January 2014 and responsible for sales and promotion of Kurare isoprene division products in India and Indian subcontinent. So we warmly welcome Mr. Moledas.
Thank you. Thank you,
Please.
sir. Good evening, good afternoon, everyone. I'll try to cover my session within time. And thank you to the organizer for giving us the chance to represent my company in this forum. Let's talk about why Kurare. Kurare is a very new company to the Indian market. What is Kurare? A company started in the city of Kurashiki with a product called rayon. So Kura from the Kurashiki city and rayon is our first product. These two combines Kurare. So we started our company in 1926, and in next year we are going to complete 100 years of manufacturing around the world. This is our vision for the people and the planet to achieve what no one else can do. So considering the sustainability concept, we try to develop, and we are committed, our management has committed to reduce the CO2 emission by 50% by 2030 and by up to 0% by 2050. This is our commitment to the sustainability, and we are committed to develop new products from the sustainability angle with the bio-based resources. This is a corporate overview. We have almost 50 plants around the world, and our headquarters is in Tokyo. We established Kurare India Private Limited as an extended arm of Kurare Group to promote its product in 2010, and we have 2 offices in India, and we are responsible only for the marketing and sales of the Kurare products. These are our product line. Knowingly or unknowingly, we are using Kurare products for more than 40 years in India. So Powell is a very well-known, I can say the product which we are using in our daily life with the Powell. Fevicol. Fevicol is, we are the raw material supplier for Fevicol. Then whatever the car you are using, all the windscreen, all the safety glasses, that uses Powell PVB film. These are the business verticals, 5 business verticals we have in the globally. And in India, we have only 3 business vertical active. Vinyl acetate business vertical, isoprene business vertical, and functional material business vertical. These 3 business verticals are active in Indian market. I belongs to isoprene business vertical and responsible for these products to sell and marketing of this in Indian and Indian subcontinent market. This is the Kurare's elastomeric history. So in 1972, we started to make synthetic isoprene rubber, that is a solid rubber, because of the demand of that time today in 1970s. But after some times, the demand of solid rubber decreases. Then our management thought how to use that facility to develop new concept, new products. Then we started developing liquid rubber with a different technology. It's anionic polymerization using some different type of specialty catalyst. And we produced liquid isoprene rubber, liquid butadiene rubber, and liquid styrene butadiene rubber. Then further development, we started to develop TPEs, thermoplastic rubbers, because to replace the thermosetting rubbers in some applications. These TPEs are mainly hydrogenated styrenic block copolymers and mainly used for the automotive and some of the special applications. In continuation to address the sustainability, we are still developing the new products based on the bio. We are using sugarcane to develop Septon series with bio-based product and liquid rubber with biosourced material. I'll come to that later on. Oh, sorry. Yeah. So liquid rubber, what is liquid rubber? It's a new concept to the Indian industry, and we are trying to promote this concept for last 7 and 10 years. Liquid rubber is a low molecular weight, synthetically produced rubber. It is not, there's no solvent at all in this product. It's very absolutely transparent, colorless, low VOC. How it improves the product and the process. So my presentation today is to explain how liquid rubber improves our processability during compounding and how it attributes to the product performance. So my focus mainly based on the tires, because 70% of the rubber industry we are selling into tires. And if that concept accepted by the tire industries, that can be implemented into the non-tire industries also. So liquid rubber has a molecular weight in between process oil and the solid rubbers. So it has a both plasticizing effect as well as behaves as a rubber during vulcanization. So that's why we call it as a reactive plasticizer. These are the grade maps. We have basically 4 grades. One is liquid isoprene rubber, LIR, based on the molecular weight and the copolymer. Different grades are developed for different type of application. Liquid butadiene rubber, same concept, different grades for different applications. LSBR, liquid styrene butadiene rubber, and LFR to address the bio sustainability concept. We developed LFR, liquid farnesene grade, from the sugarcane. We extract farnesene monomer, beta farnesene, from the sugarcane, and we used our unique polymerization technology to develop liquid farnesene rubber, which is mainly used into the tire at the moment. So these are the typical properties of different type of grades. Depending on the properties and the product application, we suggest the grades to different applications. So how liquid rubber can be cross-linkable with the base rubber? So as per our R&D studied in Japan, we witnessed that liquid rubber having molecular weight less than 30,000 can be used as a process improvement, as a plasticizer. Liquid rubber having more than molecular weight more than 30,000, it can be used as a base rubber, as well as it can be used to improve the processability of the rubber compound during compounding. So that's why molecular weight, low molecular weight as a oil replacement, high molecular weight as a rubber replacement. I'll come to that point later on while, yes. These LIR50 is the most commonly used grade, which is used in India and around the world. Someone was saying that a high hardness compound, where people are using 80 PHR, 85 PHR carbon black. This is the grade which can be used to improve the dispersion of the carbon black or filler into the rubber matrix. So I'll just show you an example. This is the effect of plasticizer. With high hardness, you need to add a lot of oils to impregnate the carbon black into the rubber matrix. So after curing, the hardness of the compound drops, but if you use liquid rubber to impregnate that carbon black, high amount of carbon black into the rubber matrix, after cross-linking, the hardness will remain almost same. So you can retain the hardness, and as well as you can improve the processability also using that liquid rubber. This is a typical compound for high hardness compound. This is typical compound for bead filler compound for tire, where the carbon black content is around 70 PHR. In practical, in India, people are using 80 to 85 PHR in bead filler compound. And they are using, some of our customers, they are using liquid rubber. So these are the typical formulation. The main point, when to add this liquid rubber in the process. We recommend to use this layer, charge the liquid rubber into the Banbury along with the fillers to avoid the slippage during compounding session. These are the typical results, how it improves the processability of the compound. You can see it with increasing the dosage of liquid rubber, the Mooney viscosity of the green compound drops. As well as once the compound becomes softer, you need less electricity to run the Banbury. That is why the liquid rubber implicates. So if you talk about, think for the short-term benefit, there is no short-term benefit. If you think for a long-term benefit, yes, it will improve. This is a typical picture. You can see with the carbon black, without liquid rubber, and with typical process oil. The control is with typical process oil and liquid rubber, with liquid rubber. You can find, witness the effect of processability on. Yes, this is a picture depicts how it smoothens the surface of extruded product. So in tire industry, mainly into the trade compound, if they use liquid rubber, the mold perfection, because in the trade compound there are a lot of intricate parts, more design. So if you reduce the viscosity of that trade compound, you can more easily can be processable. You can, with a very less amount of energy, you can, people can impregnate it to the difficult region of the mold. And it will, not only it will improve the processability, it will improve the dispersion of the filler. You can see the same photographs. You can find that liquid rubber improves the uniform filler dispersion within the rubber matrix. Reduction of mixing temperature. When we do the mixing in Banbury, the temperature goes up. So if there is a comparison done by our R&D in Japan, you can see how the temperature at peak reduces by using liquid rubber. It's a new concept to the industry, and people in India, they are getting into that, mainly the tire and the tire industry, and in non-tire industry, I'll come to later on for the non-tire industries. One of our grade, that is LSBR, liquid styrene butadiene rubber. This is used for damping characteristics, mainly into the automotives. Non-tire application, damping sealants. Or damping automotive sealants is our best customer at the moment. And some customers are using LSBR for racing tire, winter tire, to improve the grip properties. These are the major two applications in India at the moment. For improving grip performance, apart from liquid rubber, we have some other products. In automotives, now the era is to make the more fuel efficient. How we can make a car fuel efficient? We have to reduce the weight of the car. How can we reduce the weight of the car? By replacing the metal parts into plastic parts. In plastic parts, mainly the polypropylene or HDPE is used in the cars. So we have some other products, it's thermoplastic elastomer, which can be readily blendable with polypropylene and will improve the damping characteristics also. I'm not covering that TPEs into that presentation because hence we are considering only liquid styrene butadiene rubbers, considering the rubber, National Rubber Conference. So apart from this, now you can see it's a TMA graph. So you can see the tan delta is shifting towards the zero, higher side. That means it improves the damping characteristics when you impregnate this product. When you use this product into the rubber compound. Liquid rubber is also used in adhesives and sealants. So this is one of our major target in India for the non-tire industry. It improves the processability grain tack as well as the adhesion. So mainly PSA, automotive sealants, and automotive adhesives. These are used. These two grades are used. Even with your iPhone, the liquid rubber, another grade, UC grade, is used in the adhesive of iPhones. It's a typical formulation, how liquid rubber can be used and what is the effect of liquid rubber. I'll come to that later on. We have used 100 PHR. Nobody used 100 PHR in practical formulations. Even it's just to show you how it improves the adhesion. Now we can see how it improves the adhesion with the control from 82 to 721, 77 to 650. Again, we are mentioning it is not only used that much of high amount. Liquid rubber is a very costly material. So we suggest all our customers to use as an additive. Maximum dosage from 2 PHR to 8 PHR, not more than that. And that, with that PHR level, you can witness the effect on the processability as well as on the property improvement. As a summary, it improves processability, it improves, it reduces temperature, mixing temperature, gives better dampening, and improve processability and adhesion strength in pressure-sensitive adhesives and sealants. Sorry. Thank you. I'm open to you for any questions.
Thank you, Mole. You know, like I was expecting, it's very interesting, and it is, you know.
Thank you.
So, you know, like this is very well said that we have to use this material wisely because cost might be higher.
Yes.
Secondly, you know, like we have to use as an additive because low molecular weight polymers are having certain advantages. You know, I think Mole can already he mentioned it, because when we are having low molecular weight materials, they might be good for your dispersion. It might be better for your electrical saving. It is good for you know, like good miscibility in the material as well. But at the same time, these are having low molecular weight. In that case, it's, you know, like properties in terms of tensile strength, in terms of elongation, definitely it will be lower. So we have to use it wisely as an additive. Thank you. And
sorry.
Yeah.
It will improve the processability, but
Correct.
it will not deteriorate the physical and mechanical properties.
Yeah, if it is used in additive form.
Yeah, exactly.
Yeah. Thank you. Questions session is open. Please.
Yeah.
Sir, can you give some idea about the polarity of this liquid rubber? Polarity, non-polar and polar.
Depending in a base, you can say it's a non-polar, but we have some grades with functionality like carboxylated grades. This gives the polarity to the rubber.
Like it is mentioned, I can
EPDM rubber?
I can brief it. You know, like these materials are having functionality, like hydroxy functionality is there. He showed carbox functionality is there, so it depends on if hydroxy functionality is there, it means it is little bit polar, you know.
So it is compatible with both?
Yeah, definitely, it is.
Depends. For your question, EPDM rubber, for EPDM is a very good soft material. To make a oil-free EPDM compound, one of my product is used. If you want to improve the adhesion of EPDM, so polarity is there in the liquid isoprene rubber. Isoprene and EPDM will not be compatible.
EPDM and polybutadiene could be little compatible, but you know, like natural rubber, it's not advisable for that. Because in that case, sorry?
Tire is actually,
yes.
natural rubber is non-polar.
LIR 403 or 410 is being used in tire to improve the adhesion between metal core to rubber matrix in tire.
And in the formulation, you are advising, you know, naphthenic oil.
Yeah.
So why do you want to put oil when it is a liquid form?
So,
just for
yeah, because we cannot use too much of oil, or we cannot use too much 100% with liquid rubber.
this is not the replacement of 100% oil. This is just an additive to get better homogeneity, better processability. It does not mean that you don't have to use any paraffinic oil, you don't have used any naphthenic oil. That is the formulation. By adding 5 pHr or 10 pHr of liquid rubber means you are increasing your efficiency in your operation, you are increasing your efficiency in your production. By increasing this, you are getting efficiency in your product properties. It does not mean it is a replacement of oil. It is not oil. It is polymer only low molecular weight rubber.
You can replace oil fully. No, you can replace.
Naphthenic oil is a part of formulation. That's all. Thank you.
Yeah.
Is it suitable for highly silica-filled NBR compound?
For silica-filled, yes, we have some grades. We are considering the sustainability approach. We have started promoting a new grade. It's silicon grafted liquid rubber. In tire trade, mainly BR, SBR formulation is used because silica is not compatible with NR, right? So NBR.
Are you asking about NBR?
Yeah, highly silica-filled NBR.
NBR.
Silica-filled NBR, okay. Silica with NBR, yes, we have taken some trial with LIR 50, but dosage is less than 5 pHr because NBR is a polar polymer, polar rubber, and LIR 50 is a non-polar one. With less than 5 pHr dosage, it improves the processability without affecting the other properties. The base property is governed by the main rubber matrix, NBR, but it improves the processability. Less than 5 pHr, compatibility will not be an issue. So we have some study. If you want, I can share some details with you.
Thank you.
And
Thank you very much.
If anyone wants to visualize how liquid rubber is look like, I have some samples. You can visualize with that.
By this, I think we can go for the next, and we can. I think after lunch you can have please it, because time is getting short, and we have to compile the third. Third, you are here only.
Okay.
Okay,
thank you.
So already, we can compile this during lunch.
Yeah, I'm over there. We can talk later on.
So let's give a big applause to Mr. Mulay Das.
Thank you.
And for nice presentation and nice product range they are having it.
Thank you, sir. Please stay back. I would like to request our session chairperson, Dr. Shailendra S. Solanki, to please present the memento to our speaker, Mr. Mulay Das. Can we hear a big round of applause for him? Thank you, sir. Please continue.
So now in the next journey for the third paper, so I will call Dr. Amit Chakraborty, Head R&D PCBL, and his topic is Mega Trends of Carbon Black Technology of Rubber Industry. So let me give a brief about Amit. Dr. Amit is the Head R&D at PCBL, having 25 years of experience and in field of polymer science and technology, composites, polymer rheology, processing, advanced filler technology. He started his career from DRDO, and followed by he was scientist in GE, if I'm not wrong, this is John F. Welch Technology Center, it's GE in Bangalore. And after completion of his PhD degree from University of Calcutta, he did postdoc from National Cheng Kung University, Taiwan. And Dr. Amit is having 15 research publications and 4 granted patents. So I welcome Dr. Amit. Please.
So good afternoon. Now for the next 30 minutes, it will be a session which will cover the mega trends of carbon black technology for rubber industry. The title I put as a rubber industry, but during the conversation, I will go a little beyond the rubber industry. I may cover a little bit of automotive industry, where some of the areas, carbon black also helping through its mega trend, automotive industry. Now, a question is that how many of you here, the audience who are present, thought that you do not have any idea about carbon black? How many? Nobody has raised their hand. So I'm considering nobody has any idea about carbon black.
It means carbon is everywhere.
But I can tell you, after this presentation, when you will go out of this room, you can close your eyes and you can see what is a carbon black certificate. Okay, that's my duty to do that. And pre-lunch, hungry, no problem. You will forget that, I'm sure. So I'm telling in the first page, I just put two photographs. These are the two R&D centers of PCBL Limited. One is on the right side, is the Baroda, and this is in Belgium. Next slide. Okay. This is the presentation outline, but I'm just skipping it for the interest of time, because even 30 minutes may be a little less. Introduction part, in the introduction part, I would say this is the vision of the company overall. And you know that vision is a thing which trigger all the activities in a company. And we are trying to develop different kind of cutting-edge solutions for our partners. Remember, partners, it could be a customer. Even we are always working with the vendors also who are supplying our requirement. And this is we are always looking for to make our workplace exciting for the people who are working there. That's our vision. Little bit about, I will take 1 or 2 minutes about the PCBL, it's my duty. India's largest carbon black manufacturer. And if you see, it is more than 650 kiloton per year is the production capacity, and with 100 megawatt green power. You are talking about sustainability. See, most of the carbon black companies, when they are producing carbon black, if yield is 50 to 55%, 45% is gas. They are producing gas, and they don't even allow a single liter of gas to go outside. They are using that gas for power generation, ultimately. So each carbon black plant always has some power generation plant, and they are not only using in their system, they are selling those power. Even we are selling those power to Gujarat, Rajasthan, grid, and even part of CESC, Calcutta Electric Supply Corporation, is also a part of these activities. And we are 7th largest globally by sales, and we have almost 75 grades. Out of that 75 grades, we have 2 different kind of category. One is for the rubber grades, around 30, 35, and there are around 40 to 45 grades, which we call as specialty grade, going for ink, paint, coating, and adhesive, sealant, now also battery application. I'm skipping little. Now, mega trends. This is the I would say forefront for today's discussion, right? Mega trends, I will tell. Now, let us see what is a mega trend. See, carbon black as a eminent semi and is very well known as a semi-reinforcing and reinforcing pillar, not new. We know it even 40 years before, 50 years before also. But what we know also, even yesterday there is a discussion, panel discussion, that automotive sector is changing very, very quickly. Automotive sector is changing very quickly. There is a change from internal combustion engine to electrical vehicle to even hybrid vehicle. We are looking for fuel cell also, and at the end, hydrogen fuel and green energy. We have talked yesterday about noise generation. We talked about load bearing capacity due to high battery weight, and this battery is not one battery, it's a battery module, it will be very high. So the tire needs to be very solid, as well as you have to consider the wear resistance, because if you increase the speed, wear, and everything will be a factor. Second one is a subset of the automotive sector. With the time, we need to increase the fuel efficiency and as well as the durability of the tire, or even for, if it is applicable for some non-tire applications also, it's to consider. Aesthetic part is important, particularly for many extrusion profile. You need very good surface, good aesthetic, good beauty, and there is no doubt, you know that there is grit content is one of the factors how we can improve there, that's an area. Among this all, I feel the most important mega trend, collaboration. See, automotive sector, there are many things. Battery, if we think of, it needs really a very good understanding of each other, of other requirement. And where is the requirement of the collaboration? This is a very good platform to discuss. I have seen in many cases people are asking some problems to some speaker. Sometimes I feel no. If you have some problem, it is always possible that he may not have or she may not have the immediate solution. So continue this discussion. Solution may come out or will come out with a dialogue and with a collaboration. Carbon black, I told about it's a prominent filler, pigment, and spacer. Conductive carbon black is one of the area which also very, very important. I'm sure the conducting carbon black also is known for a long time. I will even say that, yes, Cabot Corporation is a pioneer in that area. They have a large number of conducting carbon black portfolio. Similarly, in India, we are also have our conducting carbon black now, which we are trying to push, I will say push, to collaborate with the different customers to improve the requirements and other. We are doing that. And feel free to, if you have any requirement, our marketing team is also here, so feel free to talk with them for different conducting carbon black. 3D printing is one area, it's a huge mega trend. Energy storage devices, not only the battery, there is another part called capacitor and supercapacitor. In a car, I will tell you more things. How even for that, there is a changes in the carbon black technology. It's not only the carbon black, hard carbon. There are a lot of work is going on for supercapacitor for hard carbon. Sensor, yesterday Dr. Robin Mukhopadhyay talked about the sensor application. So that is one part, and sustainability discussion is going on a lot on this over the last 2 days, and today and yesterday also. So that is one part. So how carbon black can achieve this kind of all metrics? Finer, the strategy should be tailoring and design the architecture of the carbon black. Architecture of the carbon black, and that is the foremost thing. Now, let us see some of the innovation pattern. See, there are two things. One is product portfolio. I have a company, I have this product portfolio, which is fulfilling the immediate requirement of the business, some other business, some other company's business. But there are many companies, they are predicting the future technology, in which direction it is going, and they are doing a lot of research work, and they are filing a lot of patents, right? And I think our next session is on that only, yeah. So very quickly, I've tried to understand in the different field where the carbon black is going, what is the status and technology trend or innovation pattern in those areas. Now see here, this is again, I use some non-paid databases only. If you see, over the last 8 years, from 2015 to 2023, this is the overall trend. This is overall trend. Maybe not all are very innovative, but maybe at least 50% is innovation in a particular carbon black field. Carbon black has a steady patenting trend you observe more than 4,000, 5,000 patents. Now, carbon black and tire also, if you see here, overall there is a normal trend is there. There is some decrease here. Maybe this is the effect of the pandemic, COVID. I feel so. One interesting part, another part, this is for carbon black and seal gasket, molded rubber goods, profile. Carbon black, somehow, the innovation trend is little less. I do not know why. I have not thought of that. But you are there. A lot of people here who are working for seal gasket. There is not anything to do new. So I do not have the answer practically. This is some of the data what I have observed. But somehow in the gasket and this area, patenting trend is comparatively less or decreasing. Surprisingly, surprising I will tell, you are talking about graphene, right? Graphene in tire, from 2015 to 2018-19, there's an increasing trend of patenting in overall. But after that, there is little bit of decreasing trend is observed. Also, I do not know why, the answer, but one reason is it could be, and that is graphene in tire. I'm not telling for any other application, graphene in tire. And it could be two things, uncertainty. People who are working, spending money for R&D, they understood that there is no immediate possibility of use graphene in tire, stop the research, and cost is no doubt, and even talked about some technical problem of dispersion and other that could be even solved. But cost is still high. Cost is still high, and high means very high. Maybe that's the reason. But surprisingly, when I am looking for graphene and seal gasket emerging, there is little bit of increasing trend, just reverse. Why? Just to understand it, I tried to read some of those patents. The observation is that mainly graphene is giving some advantage of thermal conductivity. Very good thermal conductivity, and there are a lot of patents. The title even is telling that thermal conductivity is improving, and the gasket and hose people who are using those things in different petroleum industry or gas industry, they could understand. I also do not have an idea. You can tell me that maybe yes, in those areas, those graphene or those gasket containing graphene may giving you the advantage of thermal conductivity to retain its compression set, its expansion, and other, and which could be useful, and people are trying to file some patent in that area. Another area, what I just, here is practically, I'm just come out of rubber industry. I just think of the battery electrode. Carbon black is used. There is how much possibility of use graphene or carbon nanotube as a material for electrode application. If you see, for carbon black also, there is an overall increasing tendency. We know there is a reason is there. It should be how we can use carbon black in the lithium ion battery, which has a demand will come if the EV comes in a large scale, or even sodium ion battery, where also maybe in future lithium battery will be replaced by sodium ion battery. So this is the tendency, a lot of research people are doing to improve that. In case of graphene, again with CNT, there was an increasing trend followed by some saturation level. So this is the innovation trend of carbon black and graphene carbon nanotube kind of material for the future application. But the question is that this is technology mega trend, but what is the competitiveness? First is that we can develop a technology. See, fuel cell, I think Dr. Ghoshal was here, that fuel cell membrane, it was invented by GE during 1960s. First Apollo mission in USA, that they used that particular membrane for fuel cell. After that, fuel cell technology itself becomes a future technology. There's practically no major growth in that area, but still work is going on. Similarly, there are many technologies developed, but practically buying power of the customers is comparatively less. There is a fighting for even 1 rupees. So if there is a huge, only 5 minutes? Okay, no problem. So again, technology, supply power, cost of technology and substitution, technology change and industry, these are the different factors which practically define it. Now, practically, what are the different carbon black property which control the megatrends? Practically, primary particle, aggregate size distribution, structure, porosity, functionality, surface morphology, phase morphology, and crystallinity. These are the different carbon black property which ultimately control this megatrend. I am again not going, maybe you are already aware of this. This is called primary particle, aggregate are not same. There's always a distribution which control. Structure is very important, porosity is important, and even the method of production is very important for the carbon black manufacturing or during the manufacturing, and morphology also can be changed by different method to get this kind of mega trend. Here I'm just telling you, so this is the hard carbon black, hard grade carbon black, this is the soft grade. You understand that there is a clear-cut difference in morphology, clear-cut, and that defines the changes. Now there are 2 options. Can we go much smaller size of the particle which increase the surface area is possible? That's the innovative grade we have. We are trying to develop more. At the same time, there are some soft grade. Can we go slightly higher in size, much smaller, bigger particle? That is also the research area what we are working, and we are trying to do that. And it practically, and different extruder profile kind of material, we have 2 different grades. For higher, smaller particle size, PRD 022, that is one of the grade, and another is Carbonex series of material, which can give much better surface finish for the extruded profile. Molecular engineering with an architecture of the carbon black, I'm just telling you. This is one concept. This concept is very old concept. Carbon black, which is there, how to increase the surface area of the carbon black. Make the surface of the carbon black little irregular. If you can make it, this is a model surface morphology of the carbon black, and this is the model surface morphology of modified carbon black. What has happened due to these surface irregularities? There's every possibility of increase the surface area, and there is a possibility of more rubber to carbon black interaction, which will reinforce the carbon black. Okay, this kind of technology is a theory. We have not practically manufacturing this, but this is the concept, novel morphology. Now, if you see, this is the normal carbon black. It is an atomic force microscopy. This is the planar. The structure is very planar. And if you see it here, there is lot of hills and valley kind of thing, which is called turbostratic fashion. So it increases the overall surface area, and it causes some improvement in reinforcement for the carbon black. Similarly, I'm going very fast. During the manufacturing technology, if you control the structure, you can introduce some protrusion kind of thing, spike into the system. This kind of morphology, we do not have this product commercially, but this can improve the compression set and resilience of the ultimate material. These are all different techniques we thought of for improvement. Now this is interesting, but I have very less time. So one is the molecular engineering by chemical functionalization. This is one of the area we are working, and that depends on the nature of the functionalization and dose of the functionalization. So what is your requirement? What you really want? Ultimately, you are somebody talking that you need a better color, right? So for better color, what we need to do here, that we have to think of. Okay, so practically this is the functionalization. Now, when we functionalize the material, the total surface energy of that particular carbon black surface will be a part of 2 different things. One is dispersive surface energy, and another is specific surface energy. Now, what is dispersive surface energy? It is the physical force, no chemical interaction, physical force. There is no chemical, but the specific surface energy is practically a chemical interaction called acid-base reaction. Now, if you see particularly this carbon black, the chemical interaction contribution, specific surface energy is very less, almost negligible for this carbon black. But if you see the total surface energy is contributed by the dispersive energy, physical force. So in this particular case, the rubber and polymer interaction, rubber and carbon black interaction will be entirely defined by the dispersive force, not by the interaction. Now, I'm just giving an example again. This is a carbon black without any functionalization. And this is the carbon black with functionalization. Now, what you see, here, the specific surface energy is very less. Here, the specific surface energy is increased. Here, the dispersive energy remains more or less same, but the total contribution to the total surface energy here, this particularly functionalized case, is a much more contributed by both specific surface energy by chemical interaction and also by the physical interaction. And that's the beauty of the functionalization, which it can bring the changes in a system. And in fact, I'm telling the next slide, this is some of our result of one functionalization thing. We have done some functionalization with some agent, which is indicated by X. I'm not disclosing what is. This is the normal carbon black, 38.42% is that particular material, which we increased to 58.57, and which is causing a decrease in the tan delta at 60 by almost 14 to 15%. We are not satisfied there. Our target is to increase further. Our abrasion resistance is increased by around 7%. We try to increase it further. More heat buildup is almost reduced by 18%. So this is one of our patented technology, actually, which is granted this year. I do not have another product. What we are talking about, conducting black. What we thought of for the conductive black. What is the target? Target is that we have this is a loading of carbon black in a matrix, and how the conductivity is changing. Initially, it is low, then suddenly increase, and then it attains a saturation value. This is the percolation graph. Initially, there is less carbon black, no network. Network is formed, conductivity increases suddenly, and then after a certain level, it is saturated. Now, the question is that what is the target? For any company, they will want to reduce the amount of that carbon black such that at a low loading, this network is formed much quicker. So we have to push this into the higher level, to the much more sharper slope. This is the target. Now for that, what we can do the increase in structure, we can do the increase in surface area, we can increase make the surface size distribution better, we can increase the porosity, and we have to retain the crystallinity of the material. This is the particularly molecular engineering, what we can do. Now, what is happening for that? I would say this is one of our products. Actually, I'm not giving in the data also, not important. We have two products, Energia 360, which can go for any plastics or rubber composites, conducting composites, EMI shielding application. Marketing team is there, you can talk with them. Another is there for Energia 3870, which is specifically for the battery application we have developed, and we are ready to even collaborate with anybody to get that kind of work. Phase morphology, I'm just telling, there is the same thing. We can achieve some improved property from a, I will take 2 minutes, 2 minutes more.
Please go. Please.
So adding two different filler to get a synergistic behavior, that's the target. A and B, when you are adding A and B, we are getting a much better performance. 3 plus 3 is not 6, 3 plus 3 equal to 8. That's the concept. Now, this is one of the typical examples. This is one filler, okay? And this is a mixture of two different pillars. You can see, if you see the TEM micrograph, you'll understand there are two different phases are there, right? And this is practically in the rubber system. We have incorporated this, and this is another one for the things we have added into the rubber system. Now let us see what is the advantage of that. See, for this particular hybrid filler, we have developed a unique phase morphology. In such a morphology, our heat buildup property is improved, our loss tangent at 60 degrees improved by around 14 to 15%, as well as scorch time or viscosities, everything remains, you can say comparable, or even E prime, means even modulus is also improved. Now, this is a booster of this particular technology, is booster in the rubber industry. It could have effect. And this is another patented technology from PCBL that is practically granted by Indian Patent Office by just 15 days before. We've got the granted. Sustainability, lot of discussions has been already done. So I'm just going through a little bit. Yes, the first thing is that what you are asking now, what is sustainability? In case of carbon black, sustainability first may come from the use of raw material. Raw material, whether we'll go for fossil fuel-based raw material or we'll try to go for some reuse material, which I think Pradeep was talking about, TPO. That is one of the area. Maybe 100% replacement is not possible at this moment, but at least 10, 20%. We cannot achieve the goal from the beginning at the top level. So how we can optimize, that's the way. Methane pyrolysis, one way. Process capability improvement, how to even improve the process, less heat requirement or less gas emissions and those things. That is one other part. And it is also covered, low polycyclic aromatic hydrocarbon. This is the requirement for many gasket or many even extruded profile shoes, belts, and everywhere. This is very important. And this is a low rolling resistance carbon black development is not directly but indirectly helping the entire value chain. What Dr. Kushal told, entire value chain you have to think of, that is helping the automotive industry. Now, one interest, and circular economy, yes, recovered carbon black, I'm not going into details of that one. Recovered carbon black is the matter of interest nowadays. Everybody is telling. The concept is that no, recovered carbon black will not work. Somebody was telling to me, but it's also telling that yes, in some of the cases for soft grade, partial replacement of is possible. One of our major sustainability achievement is EcoVadis is rating gold. We have EcoVadis is rating gold, and in fact, we are also trying for ISCC certification. The process is going on. And hopefully we'll get it very soon. Now, I'm the carbon black technology. I would say not the carbon black technology, carbon technology covering graphene, carbon nanotube, or carbon dot, or even hard carbon, that is progressing. And it will progress, I'm sure, more. And more and more applications will come, and that will add, we can add more and more value in that particular area. Technology focus is changing from carbon black to graphene, carbon nanotube, hard carbon, recovered carbon, and those are the areas. Due to time constraint, I'm concluding very quickly. My sincere thanks to PCBL Limited team. It's not we have done a lot of work. That is not only by R&D or somebody, it's from the manufacturing, quality, process technology, marketing team. They are coming up with the problem from the customer. And so I'm really acknowledging the entire team for the PCBL, and no doubt All India Rubber Industries Association's committee, because in this particular topic, this is my first talk. So, and I just try to take the main ideas which is possible for any future requirement. You can approach, talk. Two things, new product development and those things we can even discuss. Sometimes problem, it needs a solution. Problems is maybe some continuous problem, some sudden problem of the product. Those things may need some thought process, even why it is happening, to predict. Okay, thank you very much for your hearing.
Thank you, Amit. So nice, we listen very carefully this, and since this session, in last presentations also, everyone is discussing on the functionality of carbon black, functionality of rubber, functionality of liquid rubbers, you know. So this gives some sort of a good intuition to us also that due to AIRIA, we are here, all of us are here, like we got opportunity to come here. And you know, like everyone is having functionality in individual. So like here, by changing the functionality in carbon, by changing the functionality in any material, the objective is to improve the function. So similar way, we can apply this to ourselves also, you know, individually. And we can improve ourselves by, you know, like changing our functionality. Thank you. So any questions, please?
Dr. Chakraborty.
Mike, please.
Dr. Chakraborty, good afternoon. Here, I'm here. This side.
Okay.
This side. Can I put the question?
Okay. Sure. Yeah.
Two basic clarifications. Two basic. Does this functionalized carbon black give the same advantage over natural rubber and synthetic rubbers?
Both. The degree of advantage may be little vary, okay? Say for SBR, BR, our observation is that it gives slightly better performance. In case of natural rubber, it gives little less.
And secondly, in case of, by using this functionalized carbon black, can we decrease the loading?
No, you cannot decrease the loading as such. But for our second case, hybrid thing, the property what we have shown, problem is that cost is very high. That property is practically, we compared originally carbon black 60 PHR and that hybrid filler 45 PHR.
But then if the loading is same, then it will add to the cost of the compound?
Now, I feel for the second, I'm telling you very frankly, that for the second thing, hybrid filler, still cost is a big issue.
Cost is an issue?
Issue. And we have to work on this.
Okay, thank you.
Any other question? So once again, you know, like, thank you, doctor. Please wait.
Thank you very much for this wonderful session. Now, I would like to request the session chairperson, Dr. Shailendra S. Solanki, to please present the memento to our speaker, Dr. Amit Chakraborty. Can we hear a big round of applause for him? Also, I would like to invite on stage Mr. Somdev Bhomik to present the memento to the session chairperson, Dr. Shailendra S. Solanki.
I will also request, you know, like the people from the right-hand side on my desk. Do we have any laser? So that the, you know, like user not to go here and there, he can use the laser on the presentation. So you should keep it here. You know, like everyone is looking. You should keep it here. You should give it to the user. You should define them, no? Is it working? So I will request you please make it sure. And inform to user also that he can use it by this. Thank you.
Thank you, Dr. Solanki. Now, Mr. Somdev Bhomik is here on the stage presenting the memento to our session chairperson, Dr. Shailendra S. Solanki. Please put your hands together. Thank you very much. Now, ladies and gentlemen, it's time for a lunch break. We meet for session 6 after the lunch break. So it's going to be of 30 minutes, I guess. Be back on time so that we can start on time for technical session number 6. See you all after the lunch. The attendees, kindly take your seats. We are going to start with technical session number 6. So I request everybody, please take your seats. Everyone, kindly take your seats. We are just about to start. Back. I hope you're all recharged after the lunch break. And now we are moving forward to our last technical session. So can we all put our hands together? We have come so far. Yes? So for the technical session number 6, before I invite our session chairperson, Mr. Amardeep Singh on stage, I would like to say a few words about him. Mr. Amardeep Singh is a postgraduate in chemistry and holds a PG diploma in International Business Administration. He started his career with Asian Paints 30 years back and served at various positions with multinationals like ICI, Johnson Matthey, Brenntag, and SABIC. Having handled a diverse range of bulk commodity and specialty chemicals, polymers, and elastometers for various industrial applications, he has a quite industry experience. He has a unique industry experience and knowledge. During his tenure with his previous organizations, he has introduced many new products in the domestic and overseas market. His association with rubber industry started in 2007 when he introduced few new suppliers for rubber chemicals and silica in the Indian market. With proven track record of successfully setting up and managing marketing operations, he joined Indian Synthetic Rubber Private Limited in 2013 and has been instrumental in establishing the marketing operation for SBR Sales. Mr. Singh is presently heading the sales and marketing function at Indian Synthetic Rubber Private Limited. Let's welcome Mr. Amardeep Singh with a big round of applause. He is going to be the chairperson for this technical session. Mr. Singh, you can preside over the session. Over to you.
Thank you. Thank you for the nice introduction. Good afternoon. Good afternoon. I'm sure we are now recharged after lunch. Generally, this post-lunch session is very difficult. But we are going to make it very interesting. Please believe me. Thoda aage aa jaiye, please. Those who are sitting in the last, if they can come little ahead, that would be really, great. So, from yesterday, we had very interesting sessions, lot of sessions. This is the last and 6th session. We had good presentations. Believe me, this session we have kept in the last because it is going to be very interesting. अब वो बात होती है ना कि पिक्चर बीच में छोड़ करके जो निकल गए उनको क्लाइमेक्स का तो पता ही नहीं चला तो वही होने वाला है. So this is what is going to happen, and we have 3 speakers who are going to touch upon various subjects which I believe are very, very useful for the industry. So starting with the first lecture, with the first speaker, we have Dr.
P. Tawamani, who is Chief Technology Officer at Winco Rubber. So I am required to introduce him, but actually he doesn't require any introduction. He is very well known in the industry. I know him from IRMRA days, and he was also with me with my previous organization, SABIC. So Dr. P. Tawamani obtained his MSc in chemistry in 1985 from Madurai Kamraj University and MTech in rubber technology from IIT Kharagpur in 1987. He received INCAB Rubber Prize for securing the first rank in postgraduate program. His doctorate and his subject was design and development of rubber track pad for main battle tank. And he has done his PhD from IIT Kharagpur. So a very, very important subject, which is very relevant in today's perspective. Dr. P. Tawamani has published and presented more than 65 research and review technical papers in various journals, conferences, seminars, and workshops, and obtained 3 patents. He was the chairman of Rubber and Rubber Products Sectional Committee PCD 13 and member of Transport Engineering Division TED 27, dealing with IS standards in tires and tubes. TED 26 vehicles running on non-conventional fuels. So very important subjects. He also represented India in ISO TC 45 for rubber and rubber products, ISO TC 31 for tires and tubes, and ISO TC 41 for belt drives. So, diverse range of products he has covered, and he has given his recommendations for formulating these standards. He has vast experience in working with the Rollins India Private Limited, Fenner India, and Pix Transmission, where he worked as VP R&D and Quality Assurance. In 2009, Government of India appointed him as Director of IRMRA, Indian Rubber Manufacturer Research Association, and later he joined SABIC. He was in Saudi Arabia for some time, and after coming back from Saudi Arabia, he is currently working with Winco Auto Industries as Chief Technology Officer. So Dr. Tawamani is going to talk on a very, very important subject. From yesterday, as I mentioned, we have covered a lot of topics. We have covered carbon black, we have also covered silica, we have covered some additives, we have covered some resins. But one of the important elastomer, that is EPDM. So Dr. Tawamani is going to talk about EPDM, and he is going to talk about the processability and addition characteristics of functionalized EPDM. So before lunch also we were talking about functionality. So again we are going to talk about functionality. So he will be talking about EPDM, and he will be focusing on the belting applications. So please join me to welcome Dr. P. Tawamani on the stage.
Thank you, Chairman, for your nice introduction. Very good afternoon to all of you. I hope, as he mentioned, afternoon session is always a difficult task. Your physical system will try to control you, rather than mental system allowing you to participate and watch what is being presented here. Okay, my topic is the processability and adhesion characteristics of functionalized EPDM rubber for belting applications. I have special interest in EPDM. When I joined SABIC, I was leading the technology on polyolefin platform. When you say polyolefin platform, which covers EPDM as well as other polyolefin polymers like polyethylene, polypropylene, and EPDM as well. So initial few months, I was getting confused. When you say high univiscosity, it represents high molecular weight. But in plastics, the terminology is quite different, melt flow index. When you say high melt flow index, that represents low molecular weight. Okay, so it took me a few days, a few weeks to get convinced with this terminology and the machine parameters. I would like to touch on the basic fundamentals. Ethylene, I have special interest because I was leading this technology for about 5 years, apart from other things also. It is a terpolymer consisting of 3 monomers, ethylene, propylene, and ENB. When you polymerize ethylene, it gives macromolecule called polyethylene. In polyethylene, you have many varieties: ultra-high molecular weight polyethylene, high-density polyethylene, low-density polyethylene, linear low-density polyethylene. You have so many varieties. Okay. Similarly, when you polymerize propylene, depending on the stereo regularity, you have isotactic, atactic, or syntactic polymers. Okay. But these 2 monomers, when you polymerize as a homopolymer, they are linear polymers, like a broomstick. When you put a broomstick, all the sticks will be aligned together. It will be very strong. Here also the molecules align, it gets tightly packed and forms a crystalline structure. That's why they behave like a plastics. Okay. Similarly with the propylene also. But when you have tight packed structure, it will not have any space for amorphous structure. A polymer to become amorphous, or to rubber, to behave rubber, it should have amorphous phase, then only it will be flexible. Then only it will have resilient structure. So if you want to destroy this stereo regularity, you need to introduce a bulk molecule. ENB is having bulk structure, it is not linear. Okay. So during the polymerization of these 3 monomers, if we control the ratio of these molecules, you will be able to create a macromolecule. These macromolecules will have a bulky structure. You would hear this controlled long chain branching. It invariably will have some long chain branching also. Because of that, these molecules ultimately form something like a noodles. It doesn't align each other. When it makes a macro structure like in noodles, you will have a lot of free volumes. When it has a free volume, this macromolecule behave like a rubber, and also because of free volume, the segments are highly flexible. You will have a high low temperature flexibility. Okay. And apart from that, since the free volume is available, this rubber can accommodate other materials. You can put a high loading of carbon black, you can put a high loading of plasticizer also. That's why, apart from all the things, the product, the compound made with the EPDM also will be much more economical because it can take higher loading of fillers as well as plasticizers. Yeah. Here, by selecting a right catalyst, you will be able to play with these 3 molecules. Okay, ethylene, propylene, and this diene monomer, Q-side monomers. By changing this, you can tailor make n number of varieties. Okay, if you have high ethylene, you will have high green strength. Similarly, if you have high diene content, curing will be faster, your physical property will be better. Similarly, with the molecular weight also can be controlled by changing the process condition and the catalyst selection. The third thing is your molecular weight distribution, which is the ratio of your weight average molecular weight to number average molecular weight. This molecular weight distribution is very, very important. Unless you have wider range, processability is going to be very difficult. But all the things can be controlled because you have 3 combinations and permutations. Okay, with that you can make changes. You can make many varieties. That's why EPDM is really a versatile polymer. No other polymer has that kind of flexibility in designing the ultimate rubber. EPDM has a special characteristics which other rubbers they do not. One is this backbone doesn't have any unsaturation, so it has a very good ozone resistance, aging resistance, weather resistance. As I mentioned, it has a free volume, it has a very good low temperature flexibility, and excellent electrical properties. There is no polar groups in the main chain, so it has excellent electrical properties. These makes the EPDM as suitable for rubber, the choice for the automotive belts, conveyor belts for heat resistant applications, roof sheetings, because roof sheeting has many years of weathering resistance, mounts and hoses, windshield glass profiles, cables and wiring applications. In addition to that, EPDM has a density lesser than any other rubbers. The density is very, very low. It accepts high loading of fillers and plasticizer, and higher loading makes it an economical choice. EPDM can be produced from bio source also. Already one company, Braskem in Brazil, makes ethylene from ethanol. So from that ethylene, already EPDM has been made with the biosources. Eco EPDM, Kelton Eco EPDM is already, the grade is available. So this material is highly sustainable material compared to other synthetic rubbers. Now I'm coming to the challenges in design and development of EPDM-based belts. This is a very good rubber, but it's very difficult to process. Why it is very difficult to process, particularly with respect to belting industries? The belting industries, a lot of changes have taken place. Now if you look at your car, open the bonnet, you will see only one belt driving many components. Taking the power from your crankshaft, your engine, it drives alternator, water pump, AC compressors, and power steering. In some cases, it will be a vacuum pump also. So many components is driven by only one belt. Earlier, we used to have many belts for driving many components. It's only one belt. This belt is a very thin belt. Okay, during the cycle, these belts are designed to give nearly 1 lakh kilometer. Okay, or lifelong, vehicle lifelong service. During the service, these belts undergoes millions and millions of cycles. Think of here, these belts. Why laser is not coming? Hello? Anyhow, this belt bends over the pulleys. When it goes to the last pulley, it bends on the reverse side. So flexing takes place on both sides, inward as well as outward also. The belt has to withstand millions of cycles. Okay? So at the same time, when the belt moves over the pulley grooves, wedging action takes place through which only the force is transmitted from engine to other components. A lateral compressive force acts on the belt. So the belt, the ribs should withstand all the lateral compressive force. That means the belt should be flexible along the circumference, should be highly flexible, so that it can withstand millions of flex cycles. At the same time, should be rigid enough to transmit the power from crankshaft to other accessories. Okay, so it should have a heterogeneous property that is not possible to design with spherical particular reinforcing fillers. So just put a carbon block or any other spherical fillers, you will not be able to get this kind of properties. There you need to have a short fiber composites. So what we do, we mix EPDM with the short fibers, and then we process it in such a way that the fibers orient in particular direction. So okay, when you do the processing, sorry, I have to go to the screen, the point is not working. So the fibers are oriented along the direction of processing, either calendering or mixing. The orientation takes place like this. So when you cut it and change the direction and bend it, when you bend along the fiber yarns, they take the load. So it will be very stiff. At the same time, when you bend it across the fiber, only the rubber matrix takes the load. Is it coming?
They are doing it from there.
Oh, okay, you are doing it. All right. Anyhow, so when you bend it across the fiber, only rubber matrix takes the load. That's why it will be flexible. So you need to make the belt in such a way that the fibers are oriented across the belt section, and the only rubber takes along the circumference. This is possible by making a thin sheet of the fibers, and then the product is made by playing up one over another. That means the EPDM matrix should have a very good bonding with the fiber. The bonding between the rubber matrix and the fiber is not good, then your heat generation, everything, the dynamic property is going to be very bad. Okay, the interfacial bonding is very important. Fibers are highly polar material, highly crystalline materials, but EPDM is a non-polar. Bonding these two surfaces is extremely difficult. Okay, at the same time, the belt should have reinforcement with a cord. It may be a polyester, it may be aramid cord or any other cord. So there also bonding is very, very important. This is a dynamic product. The composite product should have very good integration of all the components. If there is a mismatch at the interface, the failure is likely to take place. Okay. So with the EPDM, achieving this is very difficult. Let me go to the next. What happened? It's not moving. Okay. This is called continuous variable transmission belts, CVT. All your scooters having a variable speed drive, or your cars having automatic transmission, all are having this kind of mechanism. Okay. This I am showing a snowmobile belt where the low temperature flexibility is very, very important. This belt should be flexible even at minus 50 degrees centigrade. Only EPDM can work at that low temperatures. That's why I'm taking this belt, CVT belt. The mechanism is like this. There are two clutches. One is a drive clutch, another is a driven clutch. Okay. No, go back. Sorry, I only pressed it. Yeah. Two clutches are there. While when the engine started, the drive clutch comes in, rises the belt, and then the driven clutch opens up. Thereby, it changes the speed. Can you play the video? Yeah, see, this is the belt which is stationary. When it picks up a certain speed, then the belt will be going up. See, from the drive, the belt is going up radially. When you reduce the speed, it will come down. Okay? The very important thing is that there will be a lot of lateral forces will be thrashing the belt from the sides. Because of the lateral forces, the belt will go up. When the force is reduced, it will come down. Okay? The belt should have enough stiffness to withstand the lateral forces. At the same time, belt should not elongate. If it stretches or wounds out, then the belt will be slipping over the clutches. It will not transmit the power. This is a highly critical applications. In all automotive auto transmission, this is a very, very important function. Okay? Such property is possible to achieve with the heavy loading of fillers, with the fibrous fillers. The fibrous fillers should have good bonding with EPDM. Again, it's not possible to achieve good bonding with conventional EPDM. We need to modify this EPDM. This is another belt drive. Earlier, in motorcycles, they used a chain and sprocket. But all electrical motorcycles are coming with the synchronous belts. Okay? I'm working with one of the leading Japanese companies to replace a chain drive with a belt drive. This belt called synchronous belts. The belt has teeth inside. The sprocket also has teeth. So it intermeshes with the teeth on the sprocket and transmits the power. Here, the teeth should be strong enough to transmit the torque. Otherwise, teeth will shear off. At the same time, the cord also should be strong enough. It should not elongate. Once the cord elongates, the pitch between the teeth gets changed. Then it will not intermesh. This kind of problem is they are really facing it. That's why they given the assignment to me. I'm working with them. So here, the teeth as well as the cord are made with a special material, which I will go to the next slide. Earlier, people used a glass cord, and later on they moved to aramide cord. These two materials are not good enough to meet the requirements. Now they have moved to carbon fiber. The carbon fiber has more than 3 times higher strength than the steel material on comparable weight basis. You look at this. If you take, can you show the pointer? When you take glass cord, the elongation at break, the strain comes around 4 to 5%. That means the cord can elongate up to 4 to 5%, but that's not good enough. Okay, the cord should not elongate at all. So when you use aramide also elongates to the extent of 2.5 to 2.8%. But high strength carbon fiber has elongation of hardly 1.2% at the break. At the service condition, literally there's no elongation. That's why in the electrical bike, the conventional chain and sprocket are getting replaced with a belt made out of the carbon fiber, reinforced with the carbon cut fiber also. So there they use carbon fiber for reinforcement, and they use cut fiber in the base composites to give enough stiffness. Okay, but these things, it is easy to put all this material, but EPDM is not compatible with all this material because EPDM is a non-polar material. That's why the functionalization of EPDM is very, very important. But functionalization of EPDM is not an easy task. Why it is not an easy task? Morning also we discussed about the functionalization. Okay. Here the functionalization is not easy. First, the functionalization is very, very important. The reason is EPDM is a totally non-polar, having only 2 elements, hydrogen and carbon, no other elements. Only 2 elements constitutes the total polymer itself. By chemical modification, we can improve the oil resistance and also compatible with all the plastic, all the textile materials. That's why we need to chemically modify this. I did a lot of work, not only the company Sabic, the other companies also like Kelton and DuPont, Dow. All these people, they worked on this to functionalize EPDM. There are a lot of challenges in functionalizing EPDM. The reason is it's a highly saturated polymer with only one possible site for reaction. This site, this is called the tertiary hydrogen. Okay, only one hydrogen is there. This hydrogen can be knocked off with a peroxide. Once the macro free radical is formed, that site can be used for cross-linking. Okay, introducing functional groups. So we also introduced functional groups like vinyl alcohol, vinylamine, vinyl ethers, like that many functional groups we introduced. But in EPDM, this terpolymer constitutes only 2.5% to 10%, not more than that. Okay? So whatever the functional groups you introduce, you will have ultimately not more than 5%, 5 to 10% of the functionalized EPDM. But 5 to 10% is not good enough. When we tried to enhance the functionality by putting more peroxide, there were other competing reactions. One is, you know that EPDM can be cured with the peroxide. So once you put more peroxide, while the functionalization was taking place, curing also was taking place in the EPDM rubber. Once the cross-linking takes place, then you can't use this material as a rubber. Okay? So this was giving a tough challenge. Apart from that, those who are with the polypropylene, they can understand, when you put a peroxide in a higher quantity, this polypropylene segment undergoes beta scission. They call it beta scission, which undergoes cleavage. In polypropylene, when they want to make high MFA materials, they put in the low MFA grades, they put peroxide, crack it, and then put in a high MFA material. Like that here also, when you put a peroxide for functionalization, the propylene segment undergoes cleavage, the molecular weight comes down. Once the molecular weight comes down, all your physical properties get deteriorated. Okay? That's why there's a real challenge. Many attempts, all patents and all research papers, they tried. They could not achieve more than 2 to 5% of functionalization. Beyond that, there are other competing reactions which are taking place. So, what we thought of alternative solutions. Okay, you have only one site where you want to introduce a functional groups. At the same time, the number of functionality should be increased. So, instead of using a monofunctional groups, which I put it here in the X may be alcohol, amine, or either anything, it may be chlorine, anything else. Okay, but all these things will give introduction of only 2 to 5% functionalized EPDM. But 2 to 5% functionalized EPDM is not good enough to give a better polarity and compatibility with the polar materials. That's why we moved to an innovative material. So instead of putting a functional group with a single or double functions, we selected a material with a polyfunctional monomers. Okay, we put one functional groups, one monomer. That monomer will have at least more than 10 functional groups, like a polydimethyl siloxane. If you take polydimethyl siloxane, vinyl polydimethyl siloxane, you have only one reactive site. Okay, if you attach one molecule, that molecule will have at least 10 functional groups. Okay, by that way, by introducing a polyfunctional monomer, we could enhance the polarity and the compatibility of EPDM. Okay, we did the functionalization with the polyfunctional monomer, which is a highly proprietary material. So this is the EPDM grade. We selected 2 grades, one with the 40 Muni viscosity, this is for the paste material, another one with the 20 Muni viscosity for the friction coating purpose. Both the materials were functionalized with the polyfunctional monomers with the peroxide as an initiator. After functionalization, a bit 4 minutes left. 4 minutes, okay, I also will come to the point. The functionalization EPDM was done in a laboratory 2-liter internal mixtures at 130 degrees centigrade for about 6 minutes using peroxide free radicals. This was confirmed through the FTR. I'll show it in the next slide. The functionalized EPDM was running smoothly on the mill. Can you play the video? Yeah. See, when you put the EPDM rubber on the 2-roll mill, it cracks. It doesn't form a band, smooth band on the mill. But functionalized EPDM, because of the presence of functional groups, which has affinity to metal surface, forms a smooth band. Okay. Move on to the next. Sorry, I will proceed. So we did FDAR. Here you can see the red color one is for EPDM and the gray one is for functionalized EPDM. The CO stretching at 1780, this peak shows that the functional group is attached to the EPDM. The relative intensity also shows that there is a substantial number of functional groups introduced into the EPDM. Okay, with that only, all the properties improved with this functionalized EPDM. Yeah, can you play the video? We made the compound, the Banbury, the kneader. After that, we dumped it into the sheeting mill. Okay, in the sheeting mill, the compound is running smoothly. Otherwise, the EPDM rubber generally has a tendency to undergo backing and sacking. When it sacks on the 2-roll mill, it is going to be very difficult for the operator to cut the sheets. He has to cut the sheets with great difficulties, and it will not be sticking to the rolls. Always it will be coming off the rolls, okay? But with the functionalized one, you can see, like your conventional general purpose rubber, the compound runs smoothly, because it has a reactive functional groups in the backbone. Not only the processability, it improved the adhesion between the fillers, particularly inorganic fillers. You can see this with the same amount of time, and the EPDM compound, standard compound, you can see the dispersion of the silica fillers. The lumps were there. It was not getting dispersed properly. But with the functionalized EPDM, the dispersion was uniform. Not only that, you can see EPDM compounds having silica fillers or calcium carbonate or any inorganic fillers, they have a tendency to undergo blooming. When you store the product for about 1 month or 2 months, you can see the white patches coming out. Okay, this happens even with when you use excess quantity of sulfur or accelerators, the unreacted material or the byproducts, they have a tendency to bloom to the surface. But with the functionalized material, we don't see such a blooming because there is a polar groups which tries to increase the compatibility, the solubility of those materials, and retains the materials. It doesn't allow the material to migrate to the surface. Yeah, coming to the adhesion, again processability. The EPDM rubber with the 20 mm viscosity is used to make the friction compound. This is the frictioning of the rubber fabric is going. Can you play once again? See, it is running in the calendar. The fabric is having uniform coating, blackish coating. The rubber pickup is uniform. Okay, the tackiness is really good. This really helped us to improve the bonding between the rubber and the fabric. Yeah, when we tested the adhesion between the fabric and the rubber in the belt or large gauge belts, we got a very good adhesion. Okay, see, the tested rubber also, the fabric also is blackish. If the interfacial failure had taken place, the fabric would have been whitish. But it shows dark color, which shows that the rubber pickup has taken place. The failure has taken place at the rubber interface rather than at the interface between the fabric and the rubber. I'm going to not two slides. Similarly, we did adhesion with a cord, with a polyester cord, which is used for reinforcing the rubber belt. Here also, see the cord, 5 cords coated with the rubber solution, EPDM rubber solution tested. The cord is completely covered with the rubber. The adhesion strength also is very good. You require minimum 1.5. It was coming more than 2.5. We made the belt, we tested, it was meeting all the requirements. That I'm coming to the end of my presentation. Since EPDM is a non-polar, functionalization is very much required to improve its compatibility with the other polar substrates. Because of other competing reactions, polyfunctional monomer is required to get adequate polarity. With the single monomer functional groups, it's not possible to get the required quantity of polarity. From FTIR spectrum, it was confirmed that polyfunctional group crafted onto EPDM polymer with the backbone. The intensity of the peak shows that there is enough number of functional groups attached to the EPDM molecule. The compound made with the EPDM polymer found to have smooth band without backing. Milling processability was really good. We could process it like a conventional general purpose rubber. Similarly, it could be friction easily in the calendar. The calendar fabric was having uniform coating. It was having smooth, good tackiness so that we could process it further. Similarly, the cord bonding was very good. The product made with this functionalized EPDM found to give a very good life. Thank you, Chairman, for giving me the opportunity to present this.
Thank you very much.
Yeah.
See how Dr. Tawamani has, by using some simple example, he made the subject very interesting and highly technical subject. He made, very easy to understand. Ethylene, and he started with ethylene and propylene, these are the two molecules, basic molecules. But what you get is plastics. But by adding, ENB, you make it a macromolecule and it becomes rubber. So very interesting. And how by using functional groups, you enhance the properties of the rubbers. Because, and especially for the application in belting industry, because that is very important component in any automobile. if belt is broken, then car will stall. So very important. Thank you very much. We have some time for taking few questions. If you have any question, we can. Yes, please.
Hi, Solanki this side. You have characterized by FTIR spectroscopy. Don't you think that functionality should also be addressed by GC or GCMS?
No, we have not done. GCN we have done, okay. Those things I'm not allowed to make a presentation here. It's the SABIC. That's why what I could present it, only those things I presented here.
Yeah, so because FTIR itself is not right to say whether it is functionality is generated.
That's why I put FTIR.
So
The
this
FTIR
functionality is chemical or it is physical?
It is a chemically bonded. That's why I use a peroxide. We created a macro free radicals. So I presented with that. When you put monomeric functional groups, you are not getting enough functional groups because your reactive site is very limited. Second thing is there is a competing other reactions. When you try to increase the number of functionalized groups with the monomeric functional monomers, it's not possible because cross-linking takes place. The propylene segment undergoes a session. Because of these reactions, really it was not possible. So to enhance the number of functional groups, the other alternatives, what we thought was to go for a polyfunctional monomer.
Because it is important to recheck whether this is physical or chemical. Because
No, it is a chemical. That's why I showed it FTIR, CO stretching at 1780.
Because CO stretching can be generated if you are adding any sort of acidic moiety in EPDM compound itself.
No, please understand, when you do scientific work, we remove the unreacted materials, you wash it, after that we do the testing. Okay, we clean the polymer, after that we remove all unreacted materials, and then after that we take a FTIR. Okay, only those materials which are chemically bound, chemically reacted, only those materials appear on the FTIR. We have done a very high level of research. What you are talking is a very low level. What I am presenting here is very industry-oriented papers I am presenting it. Otherwise, we did a lot of work. We got many patents also on this, related to this. Polyfunctional monomer is very important things. Without that, functionalization. Because EPDM, once you functionalize with enough quantity of functional groups, its application can be manifold.
What is the functionality? What is the
I showed it as CO.
MW by Mn ratio, how is it?
I showed it the CO as a functional group introduced.
What is the functionality?
The functional group.
Functional groups are attached.
No.
Functional group is CO.
No, that is okay. My question is, what is the MW by Mn ratio?
You are asking MW by Mn ratio.
Yes.
There is no change in the MW Mn ratio because molecular weight distribution base polymer is same. We kept around 2 to 3. Okay.
Means functionality is 2 or less than 2.
No, functionality what we introduced many more than 25 because the polyfunctional monomer has more than 25 functional groups in each one. The I'm not disclosing those things because they are commercial things. That's why I'm not putting those things. Okay. The polyfunctional monomers what we selected has more than 25 functional groups of same elements or different elements. Okay, but I showed CO as one of the elements. Right? These elements, by introducing one molecule, I'm getting 25 functional sites. Okay, so I can incorporate up to 5%. 5 into 25, you can think of, okay, how much molecules would have been introduced into that. With that only, there is a substantial improvement in the polarity of the functionalized EPDM, which is reflecting on the physical properties, the adhesion, the processability, and all other parameters.
Thank you.
Yeah. No, it is not. It is not. Yeah.
First is, what is the criteria to select these polyfunctional monomers? Like, which can be used and not? And what are the different types of polyfunctional monomers which can be used to functionalize EPDM?
That's what I gave an example, polydimethyl siloxane. This is very common published, it's available in the public domain, which can be easily incorporated into that. Okay. Once you introduce one vinyl polydimethyl siloxane, then by attaching one molecule, you can get 25 to 30 functional groups attached to the EPDM molecule. Okay. I gave an example of vinyl polydimethyl silaction, but when the functional group what we use is a highly proprietary PFM. That's why it's having very good commercial values. We have not disclosed it.
Actually, one more I wanted to know, like, is there any criteria to select this polyfunctional monomer, like molecular weight of that polyfunctional monomer, some range, or it can be any?
It can be any. The degree of your functionalization and the conditions on which the functionalization takes place all depends on the selection of the polyfunctional monomers. Not every polyfunctional monomer is going to attach to the EPDM. Okay. One simple example I gave polydimethyl, which is very common, which is available in any published literatures. That's why I referred that one. Otherwise, it's a highly proprietary polyfunctional monomers, okay, which gives a lot of improvements in your processability as well as addition with your substrates, polar substrates.
So, Dr. Tawamni, I have one question. Myself.
Yeah, okay. I was looking at the audience side. Yes.
So this functionalized EPDM, does it require some specialized equipment to process, or normal whatever we were using?
No, specialized conditions are required.
Okay, not the equipment.
Yeah, specialized conditions are required.
Okay. So I think we don't have more questions, and if there are any, we can have during tea session. So, हाँ जी?
Tea.
हाँ नहीं टी उसके बाद में चाय भी तो पीनी है. Thank you very much.
Thank you.
So,
I thank the organizing committee for giving this opportunity.
Thanks a lot.
Thank you. Bye.
Thank you so much, sir. Now I would request the session chairman, Mr. Amardeep Singh, to present a memento to our speaker, Dr. P. Tavamani. Can we have a big round of applause for him for this beautiful presentation? Dr. P. Tavamani, Chief Technology Officer, Vinco Auto Industries Limited. Thank you, sir.
So our next topic is actually, we have been discussing about raw material, right from yesterday and today morning. The next topic is actually not related with the rubber processing or rubber industry, but is related with rubber industry in a big way. See, all of us, when we are producing our goods, we are manufacturing our goods, or we are selling. So there are a lot of, taxations which we come through. We are importing our raw materials. We are also exporting our goods. So when we are doing these transactions, there are various laws which are applicable, which we need to understand thoroughly. And probably there are a lot of laws which, we are not aware of, and we can take benefit of them. Like in GST also, we have maybe, some provisions we might not be aware of, and we can take some benefit out of it. So our next presenter is going to talk about those laws, and she is Ms. Shweta Jain. She is going to talk about the benefits and issues in customs and foreign trade policy and GST. So Mrs. Shweta is basically an advocate, and she is also qualified company secretary. She has experience of more than 15 years in indirect tax, including customs, foreign trade policy, GST, FEMA, income tax, and other allied laws. Before joining RSA Legal, she has worked with RSA Legal, and she has also worked with PwC. She has provided various options, advises, due diligence on indirect tax litigations, including drafting of replies to show cause notices and appeals, and representing before various high courts, CSTAT, and other adjudicating authorities. She has been advising the clients in the area of tax planning, advisory, and compliances. She has extensively worked on GST, customs, and foreign trade policy, and has also authored various books published by taxmen and commercial law publishers. Books authored by her include India's Foreign Trade Policy, Faceless Assessment in Customs, section-wise commentary on GST, customs, tariffs, etc. And she is an avid writer of articles and a speaker at various forums and associations. So please join me to invite Ms. Shweta with big round of applause. Thank you.
Thank you, sir, for the warm introduction. So as sir has very rightly pointed out, that it's not specifically pertaining to any technology-related issues in the rubber sector, but definitely it touches the rubber industry in a very big way, because it impacts your procurements, it impacts your sales, and it impacts your business as a whole. So today, what I will be dealing with is particularly what are the various kinds of benefits that are available in the customs law, various kinds of benefits available in India's foreign trade policy, and also in GST. So basically, we will look at how we can streamline our procurements, our sales, so that at least we can have the least impact of the taxes and the duties on them. Because as we all know, when we import the goods, on that the customs duties are levied, and those customs duties, basic customs duties, those are core costs to the businesses, complete costs. There is no set off for them. So if we can manage in some way that we can mitigate those duties, or we can lessen those duties, then it's always in the interest of the business. So I'll be touching upon the benefits also, plus what kind of issues they may have on the industry as a whole. It's not moving forward. Yeah. So under the customs law, I'll be dealing with the duty drawback. Then there is a scheme which was brought in by the government by the name of Manufacturing and Other Operations in Warehouse Regulations 2019, which we call it as a mover scheme. Then there are various kinds of exemptions, unconditional exemptions and conditional exemptions. And then there are various free trade agreement benefits available to the imports from various countries with which India has the FTAs. The duty drawback scheme. There are typically two kinds of duty drawbacks when you export the goods out of the country. I would just like to pinpoint as to what is the meaning of duty drawback in the first place. So when we import the goods, we pay duties. Thereafter, we manufacture the product out of those raw materials, whatever we have imported. Then we export those goods. So since we have already imported the goods and paid the duties, the concept is that the goods should be exported and not the taxes. So therefore, the government gives a benefit of those duties which you have paid in the form of duty drawback. It's not that the duty drawback is always given only when you import the goods and then you manufacture and export. If you also procure the goods domestically, raw materials, if you're procuring them domestically, you manufacture the final goods out of those raw materials. Thereafter, you export the goods, still you can claim the duty drawback. The reason is simple, that government believes at some point in time, they have already fixed the duty drawback rates. So according to those rates, you can claim the duty drawback, because while doing the rationalization, the government has already seen through various data as to when you are procuring the raw material from the domestic industry, what kind of taxes you are paying, which are non-compensatable, and for those raw materials also, it could be possible that the person who is selling, he might have imported certain raw materials for that raw material from outside India. So therefore, they take into account all those taxes and they fix a rate for the duty drawback. So there are two types of duty drawback. One is Section 74 under the Customs Act and one is Section 75. Say 74 deals with the re-export of goods. This is in case wherein at times you import the goods you import raw materials, you import capital goods, and what happens is, due to some or the other reason, they never go into your manufacturing process. You don't use them at all. Maybe they are defective, maybe due to any other reason, and you are required to re-export them. Then what happens? You already paid 10%, 12%, 20%, 25% as duties, which is a huge, huge amount. So in that case, you can claim the duty drawback under Section 74. So on this, if the goods are re-exported as such without doing any kind of manufacturing on them, so on that, the government allows you to claim the complete refund of the duties on the 98% of the value. Basically, if on the 100 rupees you paid 20 rupees as the duty, then in that case, basically 20%. So when you re-export, on that, you will be given 20% of 98. So basically, some processing cost, you can say that after deducting 2% value, the government will give you back. But for this, you will have to apply to the government, you will have to follow up with the government. It's not an automatic process, and thereafter you will get this refund from the government. The second is the Section 75, which I explained that this is pertaining to export of manufactured goods. In export of manufactured goods, there are also again two types of duty drawbacks. One is all industry rate duty drawback, the other is brand rate of duty drawback. When we talk about all industry rate of duty drawback, the government has fixed the duty drawback rates for almost all the HSNs. The rubber products, they fall normally in HSN 40. HSN is the harmonized system of nomenclature fixed by the World Customs Organization at the WCO level and the WTO level. So they are globally same at the 6-digit level. So rubber products usually fall under Chapter 40, and for those Chapter 40, the all India drawback rates have been fixed from 0.15% to 5.2% of the FOB value of the export. So irrespective of the fact whether you have imported something, some raw material, you paid some duties on them, how much duties you paid, it is irrespective of that. And when you are exporting, you can straightway, this is a simple method, automatic method, nothing to be followed up with the government, no requirement of going to any law firm or a CA firm. It is an automatic method. It just happens like when you're filing your shipping bill, you need to indicate that you will be claiming the drawback. If you have checkboxed that particular column, and automatically once the goods are exported, within 10-15 days, the drawback will come to your account, bank account, directly by the government. So this is the simplest method, but the point is that it ranges from 0.15 to 5.2. There could be many times wherein the customs duties paid by you at the time of import, they are huge. But the drawback that you are getting is very less, quite possible. So in that case, there is another option of brand rate of duty drawback. So if you are not satisfied with the fact the duty drawback rate for you is very, very less, then in that case, you can make a representation to the government with all the financials, with all the data as to how much costing you are incurring for the duties, proving yourself, and thereafter you can get for your very product. It will not be applicable to everyone else in the industry. It will be for you only as an exporter. So you can get your rate fixed, and every time when you export, once it is fixed, every time once you export, you can just tick on that, and you will be granted the duty drawback at the fixed percentage that has been fixed for you. So this is brand rate of duty drawback. But as far as in this entire scenario is concerned, you must have noticed that I did not say in Section 75 specifically that you will get the refund of all the tax duties that you have paid at the time of import. I did not say this. I said either you will get it at an all industry rate or you will get it at a brand rate. It could be obviously different from what you have actually paid. It could be more, it could be less, so it happens that way. Because there are other schemes which allow you to claim that actual duties that you have paid at the time of import. So issues typically in claiming drawback is, many a times I've seen that in a haste, while the goods are being exported, many a times the clients are not even aware that there is a duty drawback which has been granted to them. So they don't tick on that box pertaining to whether they want to claim any kind of duty drawback on that. and they lose out on that quantum. So if I'm saying 5.2%, let's assume it's just 2%, and it's on the FOB value of the export. It has nothing to do with the duties. So if you're exporting goods worth, say, 1 CR, and the drawback rate fixed for you is 2%, then in that case, it's flat 2 lakh rupees which you get into your account, which if you're not clicking, you're directly losing it. So this is the key thing that you need to beware, that you need to click on that while claiming this drawback. The second is why this government gives the drawback. The purpose is that you're earning the foreign exchange for the country. So in case, many a times it happens that when you export, you don't realize the foreign exchange, or there are some negotiations while you have exported, and thereafter due to any quality issues or any other circumstances, there are price negotiations, and you don't realize as much as the amount that you have charged for your goods. So in that case, the government will typically ask you to surrender the benefit that you have taken. So whatever benefit you have taken, you have to typically surrender the quantum by which you have not realized back to the government. So this, you need to keep a track of it, otherwise the government will definitely issue the show cause notice on you. So this is one of the challenges, that surrender of duty drawback, wherein there is a requirement that every 6 months, all your reconciliations with respect to whatever you have exported and whatever you have realized, that is required to be submitted to the department, which many exporters, many means I would say more than 50 exporters, 50% of the exporters are not doing it. They don't submit the reconciliations, and thereafter on certain point in time, after 2 years, 3 years, they face the notices from the government. Withholding of drawback by authorities. So this was bound to happen. Earlier this scheme was not automatic, as I mentioned, and this was manual, wherein you had to file, you have to go to the department, and they will accordingly, look into your papers, and then they will sanction. And in that process, we all know how they work. So when the scheme was made automatic, but some kind of discretion was still with the departmental authorities. So at times in between, somewhere, in 1 month, 2 months, they will just, without any reason, they will withhold 1 of your or 2 of your duty drawback claims. So in that process, you don't even come to know, most of the businesses don't even come to know, they think, no, our money is coming regularly, we are regularly taking it, and in every 10-15 days the money comes, so we are satisfied with it. They don't see whether it's coming for all the shipping bills or not, and at times we have seen that the missed shipping bills run into, the benefit on that runs into crores of rupees. So that is one exercise, one challenge which one needs to take up. The second under the customs is the FTA benefits, free trade agreements. As we all know that India has various free trade agreements with many countries. The recently being the Indian-Australia, and now with India-UK also being going on, and with India-Europe, Switzerland, all, they are also in the pipeline. So what happens with those agreements? So when we import, once the agreement is concluded and the rules are framed in that respect, then once we import the goods, in that case, either the concessional rate of duty is applied or complete exemption. Complete means 0% duty. You are required to pay complete 0% duty subject to the fulfillment of certain conditions. So if you are importing from these countries, then in that case, you will not be required to pay any duties. First I'll run through which all countries we have the benefit, and then I'll come back to see as to what are the issues. Or maybe I can explain it right away. So the requirement is that if, say, India has an agreement with Singapore, and if you're importing from your raw material from Singapore, then in that case, there should be a certificate of origin which your exporter has to provide to you, and that certificate of origin will typically say how much value addition was done in Singapore, what process he undertook. He will have to give the details of his manufacturing process also to the authorities and all, and thereafter he will give you the certificate of origin. Once he gives you the certificate of origin and you file the bill of entry with the customs for the import of the goods, you attach your certificate of origin, mention the notification number, and thereafter you can claim the customs duties to be 0. And customs duty, as I mentioned, they are complete costs which are normally ranging from more than 10%, 15%, 20%, they're like that. So it's a huge cost. So you can check out as to and think as to whether you're taking the benefits of the FTA or not. There were rules introduced in 2020 because prior to this, these provisions were very much misused in the country. The reason for such misuse was that people used to get fake certificate of origins from the foreign country. So there they used to go to the department, their authorities, get the certificate somehow, they just give to the importers. Importers used to just produce the certificate of origin and claim complete exemptions. And thereafter the department used to challenge saying that we know that for this raw material is not even manufactured in that country. There has been so many scenarios. And the people used to go to courts and courts used to say nothing doing. If there is a condition that the importer has to produce certificate of origin and he is produced, then his liability is over and you cannot penalize him. So therefore these new rules were being framed with effect from 2020, wherein the responsibility to prove that the goods, the raw material has originated in the country X. Say if you're importing from Singapore, then in that case that raw material has originated in Singapore, it's the importer's responsibility to prove that. For that, he will obviously make a due diligence of the exporter. Maybe he might himself visit the exporter, look at his factory, get various proofs that yes, this is the manufacturing process that he follows. Apart from that, he'll keep the regular documentation also. He might also take various declarations from him. And then once he is satisfied that he has taken reasonable due diligence, then definitely he can just prove that he is in compliance with the Carota rules, and he can simply by just, it's not that he's just producing the certificate of origin, he is doing much more than that, and he can claim the benefit. So we have bilateral trade agreements, India, Sri Lanka, then Nepal, Bhutan, Thailand, Singapore, South Korea, Japan, Malaysia, Mauritius, UAE, Australia, Afghanistan, Chile. Then we have regional trade agreements. Bilateral is when it's between two countries. So if you're importing from any of those countries, then in that case, either there will be concessional rate of duty, but I have checked for chapter 40, it's majorly nil. Majorly nil. There could be in some FTA, there could be some concession or conditional, but otherwise it's majorly nil. Regional trade agreements, when we say regional trade agreements, it means that is an agreement not between two nations, but between various nations as a region as a whole. So if you're talking about regional trade agreements, we have SAFTA, which is South Asian Free Trade Agreement, which is between Bangladesh, Bhutan, Maldives, Nepal, Pakistan, Sri Lanka and Afghanistan. So if inter se any of the goods are procured or sold in these countries, then in that case the duties on import will not be levied. If you're importing goods from Maldives, manufacturing them, selling to maybe outside the SAFTA country or whether within the SAFTA country, the duties will not be levied. Similarly, India, ASEAN, wherein the countries are Cambodia, Indonesia, Laos, PDR, Malaysia, Myanmar, Philippines, Thailand, Singapore, Vietnam, Pacific Trade Agreement, Asia Pacific Trade Agreement, which is Thailand, Bangladesh, China, Republic of Korea, Sri Lanka, India, Mercosur, Argentina, Brazil, Paraguay, Uruguay. So there are many, many countries through which the imports and exports you can always explore as to if you can import the goods to those countries and get the maximum benefits. Yeah. इससे भी पहले वाली अच्छा It could also be possible, you must have noticed, that if we talk about, say, Thailand, India has standalone agreement also. It's also a part of the regional trade agreement. It's quite possible that maybe in standalone agreement there is no benefit. You need to check it into the regional trade agreement. Maybe there is a benefit. So that's how you need to explore. Then interestingly, there are various unilateral trade preferences. So unilateral trade preferences is, one is general system of preferences. This is typically for exports. And the other is a duty-free trade preference scheme for LDCs, which is typically for imports. So when you export the goods to these countries, US, New Zealand, Belarus, European, Russia, Canada, Norway, and Switzerland. So when you export the goods to these countries, the importer there in those countries, he will get the benefit. So he will not be required to pay duties on his imports. So you can accordingly negotiate with him, कि look boss, if you are purchasing it from me, and this is, there will be no duty in your country. You will be saved of this 20%, 25% duty also. So you can accordingly negotiate your agreements with them, because in the exports to those countries are duty free. Now you will ask a question as to why is it that it's only exports, not when we import from these countries. So in terms of the WTO, what happens is that the developed countries or the developing countries, they need to give the benefits and preferences to the countries which are under them, below them. Like the developed countries will give the benefit to the developing countries. There is an obligation cast on the developing countries also to give the benefits to the least developed countries. Because we all, including India, more than 200 countries are signatories to the WCO. So it is in that context. So this LDC, which is the next one, this is just the opposite of the above, wherein approximately 50 countries from Asia and Africa, which are least developed countries. So if you are importing from those least developed countries, which are 50 countries approximately, then in that case, India, you will not be required to pay any duties in India. But reverse is not true, that if you are exporting to those countries are not in a position to give you the benefit. So these are not per se agreement, but these are agreements which are flowing from the commitments in the at the WTO level. So once you import, this is how you should streamline, see whether you are able to take the maximum benefits so that there are least costs upon you for the duties. Second scheme, rather third scheme which I would be discussing under the customs law is the mover scheme. This is a recently introduced scheme in 2019. Why I would call it recently is because after 2019, 2 years or so passed in COVID, so people were not even aware, they don't want to shift their structures and everything. But now it is again gaining the momentum and popularity. And how this scheme works is that wherever your factory is, you can get your factory as converted into a bonded manufacturing facility. And after converting this into a bonded manufacturing facility, whatever goods you import from whichever country, raw materials or capital goods, both covered, those will be completely duty-free, no taxes on them, completely. However, it's not that there is any kind of export obligation fixed on you. If you are manufacturing the final product and you are exporting, then in that case, well and good. This is what the government wanted, that you should export. So no duties at all, nothing to be done. It's just monthly compliances that you need to fulfill. You need to file your monthly returns for this as to how much you imported, how much you exported. And if there is a scenario that quite possible that out of those imported raw materials or imported capital machinery, you are manufacturing and selling in the domestic area, not exporting. In that case, definitely you will not be, this is not the intent, because the government wants that if you are importing, you should pay duties on it. So in that case, whenever you make the domestic clearance of the goods, at that time you are required to pay the duties, not on the value of the final product that you are selling in the domestic market, because obviously that will be higher. But you will have to compute your duties which you have foregone at the time when you imported, and accordingly only that much only you will be required to pay. So this is a very, very good scheme, especially for those people who have maybe domestic sales also, exports also. So therein they can, choose between when they export, no taxes to be paid. When they sell it domestically, they just pay the taxes. That's it. For core exporters, this is a very, very good scheme, and who are importing the raw materials also. But I would like to say, even who are not even exporting, but only doing the domestic transactions also, in that case also, they can also take some kind of benefit, in a sense that one is that you get that shifting of or leverage of the delayed payment of duty. So if you have imported today and you are selling your goods, maybe in your cycle, WIP cycle is say 1 month, 2 months, whatsoever, and you are selling your goods accordingly, you will be required to pay duty for after that. There's a deferred duty payment. So if you calculate the interest cost factor, then that can also vary depending upon how much is the quantum. Secondly, for the capital goods specifically, because capital goods are costly, they require huge capital cost. So when you import them, otherwise you will have to pay upfront duty if you don't have any exports. But if you're under this scheme, then in that case, till the time you're using the capital goods, well and fine, you have not exported, no issue. After 10 years down the line, when it's scrap, typically when it's completely depreciated and it doesn't have any value, at that time, whenever you will sell the machinery, you pay the duty at that time, whatever duty you have foregone at the time of import. So, especially for new businesses, what happens is that because if there is a duty cost of say 5 CR or 10 CR on the import of capital machinery, and taking out this much cash from it may be difficult. So in that case, what happens is people go for this, and because after 10 years or 5 years, obviously their business is running now, they have enough cash, they can, at that point in time, they can choose to pay the duties. So this is one scheme. Since I'm getting the warning for the timing and I'm still on customs only, I'll move forward to foreign trade policy and GST also.
Please try to conclude in the next 5 minutes.
5? Okay. So sale from bonded warehousing, I already explained. The disadvantage of this scheme is that it's a bonded warehouse. You will be subject to regular customs audit because obviously you're not paying any duties, so government wants to keep a control over your operations. So that is the biggest disadvantage that a person has. But otherwise also I would say audits are for everybody. In any case, for normal units also the customs does the audit. No interest charges, duty deferment, re-export flexibility, I've all explained. Oh, sorry. General exemptions. So customs law, if I talk about general exemptions, you should also check while import if you're not going into any of the previous things. So while importing, you should also check there are various exemptions which are provided by the government and through various notifications. Some are conditional exemptions, some are unconditional exemptions. So you should always get the same checked from your lawyer or a CA, if the CA also does work in customs. But then you should get it checked whether there are any kind of exemptions. When I talk of conditional exemptions, many a times conditional exemptions are such that if you are importing the goods which are to be used in the manufacture of the products, whether you... Okay. 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 Thank you very much. Thank you. So there are various exemptions. When I talk about the conditional exemption is such that the government provides exemption. There are called IGCR rules, which were brought in 2022. Earlier they were in 2020, they were then 2017, and before that somewhere in 1994 or 1996 they came. But now, as of now, what's prevailing is IGCR. So the government provides conditional exemption to the fact that if you are using them in the manufacturing process, in that case, 0 may not be the thing, but if your goods otherwise as a tariff rate it's 15%, but you commit to set up a manufacturing facility because the government also gets a benefit out of it. So in that case, you can import the raw materials at say 7.5%, maybe half the duties may be levied. So there are, Chapter 40 also has those kind of exemptions, conditional exemptions. There are entity-based exemptions, product-based exemptions. When I say product-based exemptions, then in such cases, the government gives the exemptions basis their end user classification. They will say, if you are importing, say, this kind of a rubber to be used for, say, mobile manufacturing, because they want to boost up the mobile manufacturing in India. So in that case, whatever classification your rubber falls in, whatever other, you're not looking into the other exemptions, you can still explore this exemption, whether for manufacturing-based, product-based, is there any kind of an exemption. So why I'm telling you is because the exemptions, there are various kinds. Maybe one doesn't suit you, the second might suit you. Maybe if second also doesn't suit you, maybe the conditional ones suit you. At least you don't get complete, but you get a lower amount of benefit. Entity-based exemptions is if the imports are being made by research institutions, EOUs, units operating in SEZs, then those are specifically entity-based. So whatever is imported in them, irrespective of whether it's rubber, it's plastic, it's anything, be it anything. So those are entity-based exemptions. So I've just given an example. The entity-based exemptions could be many more entities also. So just for an example, I've mentioned that research institutes or EOUs or SEZs. The issues while claiming these kind of general exemptions is self-claiming. There nobody will, nobody else will come and assess for you. Because this is a benefit. The customs officer will not tell you that you can claim this benefit. He can tell you you are required to pay a higher amount of duty, you are paying a lower amount of duty, but wherever there is a benefit, he will never tell you that there is a benefit and you pay the lesser amount of duty or don't pay the duty at all. So that you only need to assess whether you are eligible for it or not, take a thorough opinion because you know how much you are going to import, how much value-wise they can impact you. Second is, this is subject to the satisfaction of the customs officer. Many times we have seen and I have encountered numerous cases specifically on exemptions wherein you are claiming an exemption and the customs officer rejects your claim of the exemption and says, sorry boss, you cannot claim the exemption under this and this due to so and so reason. Maybe you're not fulfilling the condition, maybe according to him, your goods are not eligible for exemption, and then you need to satisfy him as to how you can qualify. So if the stakes are high, if the amounts are high, just because he is saying it should, I would not say that you should just agree to it. The reason being because for them, their target is getting as much as revenue for the government, but for the industry, your target is to be legally compliant and claim as much benefit as you can, which the government has legally given to you, nothing doing illegally. So these were the four customs benefits which I have discussed. There could be many more, but these are the primary ones that I have covered because of the shortage of time. Now I'll move on to foreign trade policy. Foreign trade policy is framed by the Ministry of Commerce, whereas the customs law comes under the Ministry of Finance. So first is this basic difference. Now when I come to foreign trade policy, the government prescribes in this various restrictions. They are entitled to make the goods prohibited, restricted, or completely free. So the imports can be either prohibited, restricted, or free. When just click the arrow. So if I look at your chapter 40 goods, so in that case, if you see here for the natural rubber, I don't know what's it, some very technical language in primary forms or in plates or sheets or strip, all these are freely importable, but there are some designated ports only through which you can import. From other ports, you cannot even import those goods. Here also, if we see all the goods here, till the last line, they are freely importable, all extended. These are pertaining to natural rubber only. However, the last, which talks about waste, parings, and scrap of rubber, other than hard rubber and powders and granules obtained therefrom, this is restricted. When we say restricted, restricted means that you are required to obtain a license from the government to import the goods. So you will have to obtain the license from the Directorate General of Foreign Trade to import these goods. Here we see all these goods are typically restricted. This is new pneumatic tires of rubber, of a kind used for motor cars, radials, of a kind used on buses and lorries, of a kind used on motorcycles, other of a kind used for bicycles. So all these kind of tires of rubber, they are restricted. For the import of these rubbers, for the import of these goods, you require a license from the government. Apart from that, the DGFT also prescribes other conditions which you may require to fulfill. Like if we see for entry 40111090, it also says diagonal and radial ply must conform to IS 15633. It doesn't mean that once you have taken the license, you are not required to maintain the quality standards. So you also need to maintain the quality standards which are also mentioned against it, but then it's also restricted. Here also if we see 4012 category, which is retreated or used pneumatic tires of rubber, solid or cushion tires, tire treads and tire flaps of rubber, So in that case, these are all also restricted, completely restricted. So basically what I mean to say is that you should check before importing any kind of product. First is the duty structure, how much benefits you can claim, whether available or not, whether there are any regulatory requirements on that to obtain any kind of license, whether there are any kind of requirements from the perspective of maintaining the standards like BIS or ISO or something. So those things are required to be checked before importing the goods itself. Just click on that arrow. Okay. Now I will move on to the advanced authorization. Yes. So there is another scheme by the name of advanced authorization. I don't know how many of you are aware of this scheme or not. So under this scheme, you can import the goods duty-free completely with the there is an export obligation fixed to it, and that is that you have to export your manufactured product within 18 months, and validity period of this advanced authorization is 12 months. So basically, if you obtain a license, in simple words I will say, if you obtain, this is a different license, not the restricted item license, but a different license. If you obtain advanced license, let's call it, if you obtain this advanced license from the government, then in that case, say you have taken the license for an amount of 10 CR. In that case, to the extent of 10 CR, you can import the goods duty-free. It need not be from the FTA countries. You can import it from America, you can import it from Europe, with whom we don't have any benefits also. It need not be any conditional, unconditional exemption also. But if you are sure that you have the export orders with you, you should definitely go in for this scheme and get complete exemptions from the duties, including the IGST. The one point missed, when we talk about FTA exemptions, free trade agreements, in that you get exemption from the basic custom duty. You don't get exemption from the IGST. So you have to pay the IGST, then claim credit on it while you make the sales in the domestic market. So sometimes, in fact, many people are faced with the problem of inverted duty structure also, wherein the credit gets accumulated because when they import, those raw materials attract, say, 18% duty, but when they sell it domestically, it attracts, say, 12%. The credit gets accumulated. So for them, taking the FTA benefit may not be really very good, because ultimately their cash is getting blocked. So in that case, they can go for this scheme, advanced authorization, advanced license scheme, wherein complete exemption can be taken, and you should have export order in your hand, manufacture and sell them outside India. These are subject to actual user condition. Once you have imported the raw material, you cannot sell your raw materials to anyone else. This is for your self-use only. You cannot sell them to anyone else. You can do the domestic procurement also. It's not that if you have taken a license, it's mandatory for you to just import the raw materials also. If you are getting a better deal domestically, you can also go for procure the goods domestically also. You will have to invalidate that letter, and then you can obtain the goods domestically.
Request you to go a little fast.
Okay. The issue is, I will not go into how the duties are to be paid. For rubber, natural rubber, there is a special condition which is pre-import condition for natural rubber subject to export within a period of 6 months from the date of import. Otherwise, what happens is there is no pre-import condition, because it's a running raw material running cycle. So you have taken the license, say today, you have some stock in hand already, you might be. It's not that one-to-one correlation is required to be shown to the government that, okay, you imported this X item, you manufactured and you exported this Y item, how this X item got incorporated into this Y item. It's not required to be shown if you have X item in your store also. But then over the running, means the in value terms, and your value addition terms. So in both these terms should be complied with, you can do it. But no, there also it's not required. One-to-one correlation exactly is not required. That can be done. That in detail we can discuss later on as to how that can be managed. But for natural rubber, there is a specific condition that it is subject to pre-import. Means you will import first, you will get a license first, you will then import, you will manufacture out of that, thereafter only you will export, only then you will be given the benefit. You cannot use your existing stock in that. And that too subject to a maximum period of 6 months. So export period is also only 6 months, whereas for other circumstances, it's 18 months, export period also.
Export is 6 months in the case of natural rubber.
Yes. Any item made of natural rubber. Then there's similar to advanced authorization scheme, we have EPCG scheme. Both you can say it's like the child of same mother. So both are identical with the difference that there we are dealing with the raw material. Here in EPCG, which is export promotion of capital goods scheme, we are dealing with the capital goods. So here, similar way, you have to take a license from the government to import the capital goods. You will describe what capital goods you are wanting. You will have to give the details of that to the government. Thereafter, you will be given the license. You import the capital goods, manufacture, use that capital goods into your industry. You have to produce installation certificates and all to the government. That's all the compliance portions that I'm not going through right now. And thereafter, you export. And once you export the goods, you will have to obtain the EODC. You have to get that license closed with the government. So the scheme is very, very simple and very beneficial. The reason is, here, when you import, there is an obligation cast on you to, which is export obligation is subject to 6 times of the duty saved on capital goods. And that is to be fulfilled in 6 years. So it's not the value of the goods 6 times. It's only the duty saved amount which is multiplied by 6 times. So suppose for an example, you imported goods worth say 1 CR, on which the duty element was say 25 lakhs, because 25% was the duty. So you will be required, so export obligation for you is now 25 lakhs into 6 times, which you have to fulfill in 6 years. And 6 years, when we say, that is the value of the goods. So it's nothing when we compare it with the value of the goods and given the longer duration of the time. And after 6 years, you have to get that, or if earlier also quite possible you fulfill it in 1 year only, you can get your license closed with the government and the matter stands fulfilled. It's very necessary to get the advanced license also and EPCG licenses also to be closed. Otherwise, the customs will issue you a notice saying that we don't have any record of the closure. You had imported these duty free. Now so much of the time has lapsed. Kindly pay the duties. Assumingly that you have diverted them in the domestic market. So therein you will have to produce, look, I have fulfilled. But for that, it's not, you have to produce the documents to them. You have to produce the EODC certificate to them, and the EODC will be granted by the DGFT, Directorate General of Foreign Trade. Service providers are also eligible for EPCG scheme, and so issues, taking of license, getting the closure, these are the only issues. At times, normally they are granted easily and closures are also done, but at times while the closures are to be done, that is the time the department creates problem, because whatever values you have declared, average export turnover and all, so people, normally when you go to any consultant or anyone, at times getting the license is easy, getting license is no big deal. So what they do is they'll take your balance sheet figure as the export turnover, they'll put it in it and they'll get you the license. But the disadvantage is that you have to maintain that, so there is a clause in this that you have to maintain the average export turnover. So whatever you were exporting, you have to maintain that, and this 6 times obligation will be over and above. Obviously, if you're importing a new machine, you should manufacture something more over the existing thing, and then only you will get that benefit. So what consultants do is, they will take the entire turnover figure from the balance sheet, put it in the average export turnover and file, and they'll get the license for you. You will be happy. But when after 6 years, you have to get that license closed, then you look, oh my God, what the mess is there. He's taken all the such high figures. We cannot, though we have already exported so much, but since he's taken so high figures and license has been issued on such high figure, we are not meeting the criteria. Then there's a problem. Road tap scheme. So under this scheme, similar to the duty drawback scheme, earlier we had MEIS scheme in the DGFT, but now we have the road tap scheme. Under the road tap scheme, again, Just similar to duty drawback, the rates are already fixed. For rubber products, the rates range between 0.5 to 1.4% of the FOB value of exports again. So whenever you make exports, you need to click on the column for that you are intending to claim the road tab benefit. Once you click that, this is not a cash benefit. You will be given the tradable scripts for this. Once you get those scripts, you can either use those scripts for the payment of the duties at the time of import, or you can sell them in the open market also. So this is how this benefit is given. Remember, duty drawback and road tab, they both can be claimed simultaneously. It's not alternative. You can take road tab also, you can take duty drawback also. Also, if you have imported the goods under EPCG scheme and thereafter you are exporting because you have an export obligation, on those exports, you will also take on that these goods will qualify for your EPCG. So all these three benefits, in fact, they can be taken simultaneously. But advance authorization cannot be taken simultaneously. It will be either advance authorization or duty drawback or road tab. But these three benefits can be taken simultaneously. Interest equalization scheme under the DGFT. This is typically an interest subsidy wherein the government offers an interest subsidy of 3% for MSME manufacturer exporters and 2% for non-MSME manufacturer exporters of specified tariff lines, not for all tariff lines, but only for specified. Some of the rubber products are also there. Coverages applies to both pre-shipment and post-shipment rupee export credit. So whatever export credit you are, at whatever rates you are getting from the bank, in that 3% will be the discount for you. Duration, so you have to apply for this scheme. As of now, it's only open for the MSME till 31st of August. And for non-MSME exporters, the window had already closed on June 30, 2024. Under the GST law, as you all know, if you export the goods, you can claim the refund of the GST that you have with you as accumulated credit, or if you have paid the tax on your outward sales also, on the export also, therein you can claim the refund of the IGST paid on your outward supplies. Let me tell you, it's not only for export, it's for supplies to SEZ also. So if you are making the supplies to SEZ also, in that case, you can claim complete refunds of your GST, whether of the credits that are lying with you, the GST, the ITC credit ledger, or for the payment of the tax that you have made on the outward. Because at times what people do is that they have a lot of credit in their credit pool for the GST paid on the inward side. So what they do is that they make the payment on the outward and thereafter claim the refund. Why? You will ask me, why do they do that? The reason is simple, because claiming refund on outward is simple. It's easy. It's automatic. So if you, the only thing required is that you will have to accordingly declare it in the shipping bill. You will have to accordingly declare it in your GSTR returns. So if both these things match, the government portal will automatically give you a cash refund into your account within 10, 15, 20 days. So that is the reason why people prefer that you first pay the tax and then claim the refund. Because claiming of the accumulated balance is tougher as against this. But it should not happen that you are paying it out of your own pocket. If it's a scenario that you can just pay it from your credit, I would suggest that. There are certain scenarios for mandatory export under LUT. Okay, let me not go into this. I'll just touch upon the scheme. So one is, if you are making sales to the merchant exporter. Merchant exporter is a person who he doesn't have the manufacturing facility. The manufacturers are different. He may be tied up to some manufacturer who procures the orders for them, export orders for them. So he is the merchant exporter. So in that case, the government has given the facility that you can sell your goods to the merchant exporter at 0.1% of the GST, be it any goods. You can just sell to them at 0.1% of the GST. Thereafter, the merchant exporter will export because he is having the export order, and since he has not paid any taxes on the inward side, in that case, If he wants for other things, maybe some small taxes are occurring, he can claim the credit. This results, this results in not blocking the cash for the merchant exporter also and for the manufacturer also, because manufacturer also would be typically charging 0.1%. However, this is more beneficial in cases where the manufacturer has domestic sales also and exports also, so that he uses his credit of GST for the domestic ones. It should not happen that by making the merchant exporter sales, his credits are getting accumulated and thereafter he has to approach the authorities for taking the refund. So what I mean to say is that you need to strategize as to that your credits do not accumulate, so that there are no cash crunch with you. You can goods that imported duty free. If you are procuring from within the country, there are also various options. Maybe you can explore them as to whether you can get them at lesser taxes or you can get them at completely duty free, maybe because he must have imported. Like if I say there is, sorry, there is a thing called a deemed export. So in deemed export, if a normal manufacturer, if a normal person, like suppose I am a manufacturer of some raw material and you are a manufacturer who is going to manufacture a final product and then exporting the goods, then in that case, and you are an advance authorization holder. So in that case, it can also happen that even I can procure an advance authorization for me to supply to you. It will qualify as a deemed export, because if I am supplying the goods to advance authorization holder, to EOU, to EPCG holder, normal any domestic person, then in that case the supplies qualify as deemed export. In such cases, either he or you, any one of you can claim the refund of the GST, even for the domestic procurements. So it all depends as to how you are structuring your entire transaction so that you achieve the maximum tax efficiency, because believe me, there is tax terrorism and the taxes are really very high, the duties are high, and those duties are pure costs. You don't get any credits for that. So if you're not managing your tax and duties proposals well, then in that case you could even end up in paying 40% taxes on your just procurements and sales. Whereas income taxes that would be levied after your financial year is over, that will be different. That will be altogether over and above that. So it's very, very important. I have just wrapped up my session due to the paucity of time. So this was my session. Let me know if you have any queries.
So thank you very much. I think we don't have time to take up questions now. So maybe we can have, one-to-one discussion if there are some questions.
No, questions may be thousands because
Yeah.
I just touched upon
That's why I am saying.
I'm Ashwani Sareen. I wanted to ask about the bonded warehouse you said. Is there any time limit for that
Once you obtain the warehousing license,
license?
Mhm.
And if I import the goods,
Mhm.
for how long time?
no time limit prescribed.
No time limit.
No time limit prescribed. You import the goods, you keep in your bonded warehouse, maybe for 1 month, 2 months. Earlier, under the earlier provisions, there were time limits, but for the 2022 rules, there is no time limit prescribed. Secondly, earlier even the license had the validity period. Now the license is not having any validity period. It's indefinite till the time you are complying with the law and there are no major violations being done by you, so that the government has to revoke your license.
Or any interest is to be paid?
No, on the domestic, this is, that's why I just ran through that slide. There was interest benefit also. So if you have imported the goods, say in the month of April, and wherein you were required to pay a duty of 1 CR on the imports, and you made the clearance of the manufactured products, say in the month of June, so then beginning of the June. So there is 2 months lapse. It's not that you are required to pay duty along with interest. If that happens, then this scheme will lose charm.
Will lose chance.
Yes. So there is no interest, zero interest. This is basically given, benefit is given only to this aspect. See, even if you're not paying the duties and you're paying after 1 year, 2 year, or 6 months, whatsoever, we're not charging you any interest.
Okay.
But once you are clearing your goods in the domestic market, that time you will have to pay duty. If you are exporting, no problem.
No, that too, partly we can do that?
Yes. You can do that partly?
I think it also depends upon the type of bill of entry.
Yeah.
Yeah, so depends upon bill of entry, type of bill of entry.
So though I can say,
No. It's for the manufacturing process. It's manufacture. It's not for trading. That's what I think you're
Yeah,
trying to
yeah,
say, right?
exactly. That's what I
Reselling-
explained to him.
Okay.
no.
It's not for captive.
My respected convener, I'm not asking for myself. I'm asking for the people who are on the manufacturing side.
I just wanted to clarify.
Thank you very much. Thank you very much. But now I can jolly well, very well say that Shweta Jain is the encyclopedia of the indirect tax.
Thank you very much.
Yes.
And we need more time. Let us take some rest out of this because it had been very hectic for us. And the time given to you seems to be very less. And you are very much energetic.
Thank you
And
very much.
Yeah, it's a very exhaustive subject.
I'm not taking chairman's words. My words are a little different. Chairman has to come with the different words. A speaker or an author needs some editing, but she does not need any editing. She's a master of the thing. Thank you.
Thank you, sir. Thank you.
So thank you
for
very
such
much.
kind words.
Yeah, thank you.
Sir, I've authored 4 books, 6 books also.
What is the difference between FTAs and PNAs?
And
PNAs, professional nation agreements.
PTAs, preferential trade agreements.
And nations like
Yes,
we have it
yes.
with
See,
Russia.
there are various, if you look at every agreement, na, the nomenclature, first thing I would like to tell, the nomenclature would be different. Some would be termed as free trade agreement, some would be termed as preferential trade agreement, some would be termed as preferential national agreement, as you are saying, some would be termed as comprehensive economic development agreement, some would be termed as comprehensive economic and IPR related, means I also they will insert in between something. So the difference that you are asking is the nature of negotiations that is being done between the governments. So what happens is, earlier it used to happen that when the governments used to negotiate, then they only used to negotiate regarding the import and export of goods. So that were, earlier agreements were known as free trade agreements, which were typically only and only for the trading in goods, wherein you import from their country, they import from your country, to give boost up to both the countries. But as the time passed, now the governments are negotiating on and covering on many other aspects. They are agreeing on the services also, they are agreeing on the exchange of technologies also, they are agreeing on the modus operandi for the registrations of patents and trademarks and all those stuff also. They are also agreeing on mutual development, like you invest so and so much of the money in my country for so much of infrastructure, I will do this for you. So depending upon what kind of agreement it has. So nowadays agreement, if you find, they are so broadly worded: comprehensive economic and cooperation agreement, CESA agreement, comprehensive economic participation agreement, wherein we say it's CEPA, like the Japan one. Japan, India has CEPA. So therein, the Japan government will also agree to invest in the bullet trains also. They will agree to many more other infrastructural developments also. So that is not merely trade in goods. So that is the reason how these nomenclatures are derived. So depending upon what kind of negotiations the government has with each other, they will keep the terminology, and all these terminologies are different with a different meaning.
All right. Thank you so much, ma'am.
But as far as we are concerned, when we are talking about goods, goods for us means trade agreement.
All right. Thank you so much, ma'am. Now I would like to request the session chairperson, Mr. Amardeep Singh, to please present a memento to our wonderful speaker, Ms. Shweta Jain Gupta, who is a partner at RSA Legal Solutions. Let's put our hands together for Ms. Shweta Jain Gupta. Thank you.
So now we have the last topic for this conference, and that is also going to be very interesting. So we have already covered, raw materials, manufacturing, but then we also do a lot of innovation, research, and we try to develop new products. But how to protect that technology, that is also very important for any business. So now we are going to discuss on the IPR subject. And for this, we have Mr. Sushanta Das, who is basically a rubber technologist. He has done MTech from IIT Kharagpur in rubber technology. And after completing his MSc in chemistry from Visva Bharati University, he has done MTech. He also holds LLB from Delhi University. And later on, he joined the patent office. So currently, he is with the he is serving as a Deputy Controller of Patents and Designs as Patent Office, Delhi, DPIIT, Ministry of Commerce and Industries, Government of India. So a person who has knowledge of rubber industry and also in the, department which is covering the patents is very important for us. So now I invite Mr. Sushanta Das. Please join me to invite.
Thank you, Singh sir, for warm introduction. And now, as all of you know, that time has already passed a lot. We don't have too much time. But what, with kind permission of Chairperson sir, I think session is open for first slide itself. Should I go for? Yes. That's it. Because I will just elaborate a few slides. And mainly, I want to convey the schemes giving or providing by the Government of India. I think I have seen the speaker list. Probably, I'm the only person from the government side, probably. So, as a public servant, you can say, I am servant of yours. So, I should be accountable whatever you have raised. And in first 3 sessions, what I have seen that Ms. Ghoshal and Dr. Chakravarti, Amit Chakravarti, as well as the last session speaker, these all 3 speakers has patents in their portfolios. So, and several times, the word patent, trademark and IPR has raised here in this dais. That means it is enough who are present here, what is the impact of IPR in coming days and today itself. That is why government has taken so much initiatives. Just 4-5 years back, those schemes was not there. But after viewing the progress and development in IPR field, as well as small scale industries, government have come up with the different schemes in different level. In universities, in small industries, in research institute, as well as tax benefit to all other companies. So now I'm not going in details what is intellectual property, as whoever is sitting here, most of you are from R&D sections, as well as few of managing R&D, those are head of R&D. So this I'm not going in details because time is very short, and I request those who is expert in this field, please give some suggestion to us, means me, so that I can raise it in our stakeholders meetings and I can convey what's the solution you want. And those sitting here who are new in this field, please raise as maximum as possible questions to me. Please make me tired of giving answer, those who don't know. Okay? So, very short I am going. Patent is all about protection of invention. Design is aesthetic appeal. Trademark is what we are seeing here, trademark. And GI is, we taken the Rasagulla here today. This is the GI Rasagulla. Have you seen? Oriya Rasagulla and West Bengal Rasagulla. This is the matter of GI. And copyright, madam has already written books. These are all dramatic work, cinematographic, and write-ups are under copyright, and semiconductor integrated circuits, which is mainly the computer chips design. So last 3 years, there is zero filing. Last 2 years, few file is registered under this. This is a very new field. As well as Plant Variety Act, it is related to the farmers. And now one can get protection in same product. Just you see the camera here, in the surface, whatever we are seeing in our sole eye is a matter of design. And whatever the name is there, Canon, this is the name of the company, and these also are name of the, is a matter of trademark, as well as what is the surface material was made of that camera is all about patents. And now we come to rubber industry. This is taken from DSIR sites. You can see how impact rubber industry is from India. It is, we are the third largest producer of natural rubber and fourth largest consumer of natural rubber and fifth largest consumer of natural rubber and synthetic rubber itself when we calculate it. And as well as 6,000 unit comprising 30 large scale industry as well as 300 medium and scale and 5,600 small scale industry. They are playing the major role in the economy, as well as manufacturing 35,000 rubber products. And as far as employment concerned, this is around 400,000 people is working. Can you imagine how people are getting employment from the rubber industry? As well as 22,000 technically sound scientists, technologists, technocrats, who has few of us is sitting here today. And as well as turnover is concerned, 200 billions is their turnover and they are paying taxes and levies as 40 billion rupees. So you can say in India, rubber industry plays a co-sector role in Indian national economy. And it is, IPR is all about business. That is why it is under Ministry of Commerce and Industry. It is all related to the economy. And I'm not going in details. I just, you just see the third point. The non-tire sector comprises the medium scale, small scale, and tiny units. It produces high technology and sophisticated industrial products. If you go to the big industries, tire industries and other industries, they have a well set up systems for IPR and not much varieties. But if you see the SMEs, they are the ample number of products and day by day they are introducing new products. Each and every day might have, they are introduced new products. And why? Because earlier it was the necessity is the mother of invention. Earlier the word is there. But now you see everywhere comfort. Comfort is comes now. A major area of invention and innovation is now comfort. Because the simple example that is given by mobile. Mobile is just for listening and calling. Now mobile is comes with the torch, with the camera, and now some computer programming is also you can do by mobile. So everybody wants comfort. So now the research is oriented towards comfort and lifestyle of the society. Now just see why I am telling government is taking too much initiative. This is the, I am concentrating on patents only because patent, design and trademark, these three are industrial design which is related to the industry. Now you see that what's the trend? Last 5 years, 50, 56, 58, 67, 82. Now it is increasing like anything, and not only this, each and every field. Now IPR has gained momentum in India. Please just remind my words, maybe after 5-10 years, India will be a huge knowledge economy market. It is already started that in the software company, if you see 50 to 60% of the software product is developed in India and it is serving all over the world. So in coming coming years, we are expecting that our sector is also blooming. And that is why you can say Honorable Prime Minister has said these words. The rise in patents application in India demonstrate the rising innovative zeal of our youth and it's a very positive sign for the times to come. So the word is coming from the Prime Minister. That means you can say how much importance is given by the PMO, this office. And another point I want to demonstrate, this is given by YPO, World Intellectual Property Office Director Darren Tang. That is nowadays, 1 decade back, in all over India, whatever the filing is, people are filing, that is out of 10, the number was 5. But now, the developing country from Asia, Africa, and Latin America, it is about 7 for every 10 applications. So slowly we are getting momentum towards research and development. As well as the YPO study reveals there's foreign direct investment. If 1% improvement in TM and 1% improvement in patents is giving 2.8% of FDI. This is, you can check it from CII blog as well as YPO study. And another point I want to share with you, please note that just 7 years back, the Global Innovation Index, this is the index, it's a very prestigious index. One can get impression of that particular country, how they are performing in their research and development. Okay, so now we are in 40, in number in 40, 2022, as well as 2023 also, we are in the position of 40. And this is all initiative taken by the Ministry of Science and Technology as well as Ministry of Commerce and Industry. Because in the same time, research papers, researchers, as well as IP has huge impact to increase that innovation index. And in the national IPR policy, there is a special provision for the MSME and small businesses because there is tremendous potential in this industry sector. That is why a lot of schemes, lot of facilities has been given to the MSMEs. That is free fee reduction as well as expedite examination, facilitator scheme, as well as wide range of awareness. And these are the schemes. You are free to raise question in between. If you have any doubt in any slides, please raise question. Because time is short. After that, you may not get time, and already all have taken all time. And whenever you get any confusion, any doubt, please stop me and ask question as maximum as possible, please. Otherwise, slides you will see and you will forget it. If you raise little bit 1 or 2 questions, you will remember it. Sorry. So this is for the startups that if you file patent, if you file patent, there is some fees for the filing. And fees is for individual startups and MSME is 5,600 rupees, and for other than that, this is 28,000 rupees. Thus, few years back, SMEs and startup also has to pay the 28,000 rupees for the application, but now after taking initiative from the government, it is come down to 5,600 rupees just to promote them, just to increase filing from them. So there is a scheme of facilitator. This is given by the CGP-DTM office. Facilitator means a patent agent. Those who are expert in this field, you may or may not know about IPR, how to file, but they will help you, and the payment will be given by the office only. But for filing, facilitator is getting 15,000 rupees, and for replying the objections, they will get 35,000 rupees. After that, if it is come to the opposition matters also, you need not to worry. For the small scale industries and startups, they need not to pay a single rupee. If opposition comes, this facilitator will stand for them, and for that also facilitator will give 50,000 rupees. And as well as the fee reduction, it is already 80% fee reduction is given to the MSMEs. Now, expedite examination. We used to keep the application 18 months. After publication, application is come to the queue. But now, any startup, SMEs can file an application in Form 18A that I need a speed up process. So, we will make it a extra queue. And in our module, this sort of case used to come as a mark red. That means within 2-3 days, within a week, you have to take action. Otherwise, office will take action against us. Okay, so that sort of check is there nowadays. Now I am already in the beginning, I am telling you, we are the servant of yours. So and we have to behave as a servant of yours. Okay? So, thank you. For 20 years. For 20 years. Sir, any IP rights is territorial. Means it is its jurisdiction to that particular country only. If you apply in India, you will get protection in India only. Now, there is another route, that is PCT route, Patent Cooperation Treaty route. In this treaty, 172 countries is there, as well as African nations, as well as Latin American nations. There are few countries. Yes. Yes, sir. So what you have to do, there is a PCT route you can apply in other countries, not approaching them. You just come to the office. There is a form RO/01, means receiving office is India, and you choose of your choices of country. Just I am giving example. Just suppose you are mosquito repellent. You have made a mosquito repellent. In Europe, there is no market of any mosquito repellent product. But in Africa, there is an enormous market. So you need not to go or opt for European countries. You just directly opt African countries, maybe Bangladesh, maybe Sri Lanka, these countries. So you have an option in your hand to choose the countries sitting here in India only. But yes, you have to pay the little bit fees for that.
So, but
yes,
what about the objections? I mean, how much time? Like this one you said is going to be a very quick express process.
Yes.
But how about those when you apply to
yes, sir.
Under that scheme,
Yes,
172 countries?
There is advantages and disadvantages both for expedite examination. If you are you have completed your process and you are just going to launch your product, then come quickly. But you are in the midway, that some finesse you have left with your product, then please delay it from your side, so that you will get around 2 years, 2.5 years. By that time, you developed it and you modify the application so that you will not incur problem in future. But once you get granted patent, after that you are not available for any amendment once you get it. So, see, patent pending and patent grant is what? Patent pending is also advantageous and patent grant is definitely beneficial. Why? Because suppose there is a 48 months, it's okay now, I am not boring now because it's okay, time is there. So, sir, okay? Yes. So, if you, suppose you file a patent file today, you have in your hand 48 months for request for examination. Unless until you are filing the request for examination, your application will not come to in queue. So you are getting 48 months in your hand, as well as office will take, there is a provision of examination of 6 months. After that, a objection letter will go to you and you will get again 6 month time. So again you will 48 and 12 months. So 60 months. So by these 60 months, you can write it patent pending. Okay, so patent pending also has beneficial because as you know, yes, now I am coming to that point also. There is a provision of filing provisional specification. As in the morning session, Dr. Amit is telling Cabot is also doing in the same carbon black, they are also doing the same carbon black. In the carbon black field, there are other companies also, Birla Carbon is there, Oriental Carbon is there, Ralston is there. So everybody is trying to capture the market. So everybody want to be a pioneer in their field. So in those cases, what you have to do? You just come and file a provisional specification. Those who come first will get the right first. So in the provisional specification, you need not to file complete. You need not to file the claim. You just come with some abstract kind of matter, but definitely you should not cross whatever you have submitted today in the provisional. You must restrict your disclosure with the purview of that provisional one. So provisional, when you file the provisional, you will get the priority protection. That means after that, if someone is come, the first one who is filed, already filed, they can sue them for infringement. Again, these are you just check the annual report of MSME just last year, they are giving that much of money. So small scale industry need not to fear for filing, because all the support is government is giving. Just you come and you explore, because this is your money. It is taxpayers' money. You have full right to explore that money. You come and claim it. Okay, these are the amount they are giving, and you have to register as a SME. Just go. There is a process. You just fill the some forms. You take the certificate from the patent office and show them. They will directly pay. There is total hassle-free online. Yes, sir. Person like me, there is 1451 person the staff strength in our office. Okay, so maybe there is some examiners, assistant controller, deputy controller, and joint controller. So they are working in this area. So you can come any one of them. I'm not going innovation and all blah blah. Okay, now how impact? What is the impact of innovation? A single innovation. See, vulcanization. All of us sitting here due to him only. We shall indebted it to him, and what he invented, the vulcanization in 1844. Patent number is 3633 US patent. So if you check in their database, you will able to see there is a lot of court battle is also there to get the patent. Ultimately, in 1852, he received the patent. But in the same time, what happened? The Nathal Manley Hedward, he knows that if sulfur is given or sulfur is mixing to the rubber, it gives the stickiness. He shared that information to Goodyear, and he worked a lot. After that, by mistake, he discovered that vulcanization. The story all we know. So a single invention can change the whole world, and it is not necessarily it should be a big invention. A single invention can have huge impact. Just simply, if we consider James Cleek, this is it's a part of where only, and it is also invented by mistake. The person, his dad scolded him, and he come to sit a place, and just in times in the action of playing with the wire, he invented the James Cleek. So James Cleek is patented in 1880s or 1890s. Now, till date is at impact. Safety pin is a very simple invention, but nowadays it is touched each and everybody's life today. So innovation has a huge impact. Whatever you are seeing, your car, your houses, if you apply your mind, if you give some creation, it is an enormous potential in innovation field. And why patent? I am not going in details, just I am saying that our earlier three eminent speakers have shown their portfolios that they have patented in their name. So, and in the carbon black also, the PCPL has patented 2-3 varieties of carbon black, and they have shown the patent number also. When one is written that product is patented, automatically a public get good impression of enterprises. So patent has so much impact. People, before 1 decade, even we go to the universities, colleges, they are telling, यार सब चोरी हो जाएगा, क्या आप लोगों को क्या करना है, गवर्नमेंट लोग ये है वो है, कुछ नहीं करते. लेकिन now whole scenario has changed, whole impression has changed. You come, you see the office is totally paperless. There is no piece of papers. Everything is in electronic module, as well as everything governed by AI. Because I cannot demand any file if it is coming to the office. Some IPC classification is there. I'm showing you. Just before filing, you have to plan something. So, but one point I want to just share, because here a lot of stalwarts sitting here, those who are owner as well as R&D managers. But here, one point you note, who is the inventor? Inventor is who, the person who gives intellectual inputs. The just only giving information or giving orders will not give you the become a inventor. So the person who is working honestly in the project should be an inventor, because there is no provision and though there is no mechanism of detecting who is inventor. We just go through by your statements, but in court cases you will be in big trouble. If someone is working in your company today and he left that job and he joined other companies, and this is the IPC, each and every product has a IPC. This is very important. You can easily search a IPC. These are the fields, YPO site for the rubber. Each and every rubber product has a IPC. You can, if you find out the IPC, then you will easily able to search the product. And you can go, this is an Indian rubber site. This is, if you give the abstract rubber, this much of document is coming. As well as another good search engine is European Patent Office site. And this is the criteria, novelty, inventive and industrial. There is some rules in the Patent Act that certain invention is not patentable, just like method of treatment, means it is directly touched to the life of the people, and government is accountable to the treatment of poorest and poorest people. So this is strictly prohibited in the Patent Act, as well as copyright, trademark. These are the applicable to other sections, but not in patents. But these are the patentable. Patentable is all process, mechanism, ideas and all. And these are the requirement of application. Main three is 1, 2 and 18. One is your formal information. Form 2, which is the technical information you have to give to the office, as well as 18 is request for examination. And these are the specification part. This is some claims should be there, and your disclosure. There is mainly 4 parts in your disclosure. One is prior art, another is objective, and what is the work already done in this field, this is prior art, and why the problem solving approach. What's the problem you are facing and what's the solution you are come up with, you have to disclose, as well as experimentation, what you have done. All the experimentation has to provide in the specification, as well as claim part, that goes to you. The claim part is the totally legal matters, and whatever the court matters is come afterwards, these are claim parts only. So writing of claim is very tricky, as well as patent is not only scientific work, not like simple paper writing, it's a legal document. You have to write in a legal manner. And this is the process of life of a patent, thus filing. This is a publication. Publication is there in weekly in our patent office journal, it is published. After the publication all over the world, anyone can see and can oppose it, as well as anyone can contact you for further development, further funding. So publication is a huge implication in the patenting system. As well as examination process, it is all inside office process. I am not going inside. In the office, we have mainly 4 categories or 4 departments: chemistry, as well as mechanical engineering, electronics and electrical, and biotechnology. Rubber technology, polymer science is coming under chemistry. Few days back also, all is coming under chemistry. Now there is a subgroup of polymer and rubber technology. This is the minimum timing for expedited examination, only 7 months you can get it. And these are the few mistakes one used to do. I don't know how much faculty is there. With due respect to them, I am telling you, the work they are doing, they usually run for the publication of papers in several international journals. But I request them, please come and file first, after that you publish your work. Because once you display your invention in any conferences or anywhere in scientific community, as well as publish your work, is become the prior art of your own invention. Now, points to be remembered: first, protect, then publish. Okay, and it is a territorial rights. Registration is done by sovereign authority and respective countries. right is limited for each and every IPOs, designed for 10 years, trademark is for lifetime, and patent is for 20 years. As well as renewal fee has to be paid. After grant, you should not forget to pay the renewal fees. If you are not paid the fees, then your patent will be seized. As well as patent agent, there is a term patent agent, as you are aware that they are the advocates, and as well as scientific people, they are the registered by the office and they passed a exam, patent agent exam. If some students is here, I will suggest you can also appear for that exam. Exam qualification is graduation in science. Okay, so you can come, you can be a patent agent. It is a wonderful profession. Okay, and if I concentrate on polymer science and technology, up to 2012, there is a no recruitment on rubber technology or polymer science people. But in 2012 recruitment, there is a starting of polymer science people. After that recruitment done in 2019, there is a examiner has come, and after in recent recruitment also, maybe they will join within a month. There is, so polymer science people, around 50 people are there. So this is polymer science, although it is increasing, 2021-22, I don't know, this is the less filing, but again in 2022-23, it is 1739. That means it increase, although it is increasing, but compared to other fields, it is very less. So I am requesting you all who are sitting here, please come and please file application in this field. And these are our office structure. We have 4 offices in 4 metros, as well as trademark registry is another office in Ahmedabad. And we are working under Ministry of Commerce and Industry. And this is our official website. If you please have a look in our official website, it's a lot of information. Those who are working in the small scale industry, there is a database, huge database of expired patent. After 20 years, that property goes to public. Then nobody can sue you, nobody can tell anything to you. You can free to make, free to sell, free to use. And after 20 years also, a lot of product is available to make a wonderful, different type of products. You just, as per your interest, you search it. There is a database of that also. You can take ideas because everything is open here and you can go for that. Nobody will restrict you. So these are our office site, as well as public search is there. You can search it. If you click, it is live that I can show you, but time is not there. And these are the reference site. You can visit. Thank you. I think I have seen. Yes, sir.
Thank you so much. Very insightful presentation. A lot of information. And that information is really, it shows that how India is progressing.
Actually,
the number of patents being filed,
yes,
it really shows, how India
not
is
only
progressing
that,
on innovation.
One good news also I can say that if you last years, if you see, the foreign applicant is higher in India. But in this year, 2022-23, if you see, Indian applicant, Indian inventor is higher than the foreign one. And I think ministry deserves the credit for that. Thank you. Any questions, please?
Good afternoon, sir.
Yes,
so,
please.
I'm facing a weird problem. We have applied for patent in September 2022.
Yes, sir.
Under MSME fast track. Okay. So the FER has been released within a year and we have replied within 2 months. Since then, we have approached the Chennai patent officer who is telling us the examiner who was looking in our case has been transferred or maybe he has changed his position.
Okay.
Since then, no one has been able to handle our case. I don't know why it is pending for so many months.
Need not to worry. There is a live session for raising complaint.
Okay.
Each Friday, I think 10:30. You just come, there is a person sitting there. You can directly raise your concern that to person. Not only that, my email ID is there. You just send me the application number. That's all.
Sure.
I assure you, within 15 days, you will get result.
Thank you very much.
Sir, one more question.
Yes, sir, please.
Normally they say if you apply for a patent or a trademark and it's your competitor, if he likes your product and stuff like that, he might just change a little things in those and then apply for a new patent.
Yes.
So how are you protecting the original inventor for this, sir?
Yes. This is a huge matter of concern for Indian drug industries. What you have raised the question. This is in our language we call evergreening. Evergreening means suppose you are this is a drug molecule and you have patented the drug molecule and you are just, and after 20 years in the verge of ending your tenure, again you come to the office and you are applying just simple change. Suppose a halogen group is there. Halogen means chlorine, iodine, bromine, all is there. Earlier it was chlorine. Now you are attaching iodine and the halogen, the property of the halogen is the same. Now you are iodine, now you are saying my molecule is new. So you are simply evergreening. That sort of invention is restricted. There is a particular section for that. That is section 3D. It is a hugely discussed section. Each and every developed country wants to scrap this section 3D. But say for the section 3D, our government is fighting for last 20 years, and I hope that section will be there in the act. No change? No. Yes? Yes, sir. No, sir. You. No, sir.
Yes, yes.
Time. No, means no, any presentation should not be listen and forget. But you should do, if introduction and discussion is there, then
Thank
it
you
is
very
beneficial.
much. Can we all put our hands together for Mr. Susanta Das, India Patent Office, Government of India. I request the chairman of the session to kindly present the memento to him.
कैसा था सर? कुछ informative था सर? हाँ?
Thank you very much. Thank you, sir. Now it is time for me to invite Mr. Subhash Jain, who will present the memento to our session chairperson, Mr. Amardeep Singh. Mr. Subhash Jain, can we all put our hands together for him? So well, here we conclude technical session number 6, and in a span of 2 days, we have had 6 incredible technical sessions. So let's put our hands together for all the speakers, all the chairpersons, and all the panelists. Thank you very much for the insightful and informative sessions. Now is the time for the valedictory session, for which I would like to invite Mr. Varun Agarwal, but before he takes on to the podium, I would like to say a few words about him. Mr. Varun Agarwal is 3rd generation into his family business, the Bharat Group, and currently serves as the Managing Director of Bharat Advanced Material Sciences Private Limited. He majored in chemistry and entrepreneurship from Ashoka University and promptly joined his family business right after. Also, very interestingly, Sir is the youngest member of IRIA Northern Region's Regional Committee. Let's put our hands together for Mr. Varun Agarwal.
A very good evening to all of you. It's my absolute pleasure to address this August gathering at National Rubber Conference 2024. An event of this stature in such a short span of time takes a monumental effort. I would like to start off by expressing my gratitude to our chairman, Shri Mukesh Kakkarji, our chief convener, Shri Ashwani Sareen our young and energetic convener, Shri Saurabh Malhotra ji, and our technical convener, Dr. Samar Bandyopadhyay. This event seriously would not have been possible without the contribution of these four gentlemen. I also wish to express our deepest gratitude to all our sponsors and speakers who assisted us to deliver this event for all the participants gathered here. This was my third NRC. I still remember the first one wherein my father was posthumously conferred with a Lifetime Achievement Award for his service to the industry. That was the day that I realized how closely knit the entire community is. From that day on, this has never changed. The IRA family has always functioned like a family. All the senior members have always been there to offer their blessings and guidance to us. I would like to thank Shri Anek Gupta ji, Shri Sanjeev Sikka ji, and Shri Vipin Mehta ji for their guidance, which was instrumental for this event. I would also like to thank Shri Naveen Garg ji for coordinating with the backstage team and handling all the audio visuals seamlessly. Shri S.K. Jain ji and Pahwa ji for tirelessly working on the souvenir. Dr. Samar Bandyopadhyay for getting the who's who of the rubber community and academia all together on the same platform. Shri Navneet ji for coordinating with the Ansh Anukriti team and saving the best for the last. Anshul Bhaiya, Harpreet Bhaiya and Anil Bhaiya for handling the stage wonderfully. Coordinating the opening and repacking of 162 mementos is a colossal task. Thank you, Harpreet Bhaiya, for your service. A big thank you to the rest of the organizing committee members as well. Shri Subhash Jain ji, Shri Amit Agarwal ji, attended all the countless meetings in a build-up to the event. Shri Rajiv Pandey, Regional Secretary, Narang ji and Mohan ji, thank you all for your service. I would also like to thank Mr. Rajiv, Mr. Rahul and the entire Ansh Anukriti communications team for handling each and every challenge thrown at them with ease. And Mrs. Kalpana Mishra, who was our MC for both the days of the conference. Most importantly, I'd also like to thank our hospitality partners, Hotel Le Méridien. A big thank you to all the staff who were tirelessly working to host us. We were thrilled to witness such an enthusiastic participation and a highly learned audience gathered to deepen their understanding of various topics curated by us. We thank each and every one of you for your participation and wish to see you in our future events. Thank you so much.
Thank you very much, Mr. Varun Agarwal, for such a warm address. Let's put our hands together for Varun, everyone. So, ladies and gentlemen, now as we come to the end of our conference, National Rubber Conference 2024, it's been a huge success. Let's put our hands together once, everyone. It is time for me to say thanks to everyone who has made this event possible. And now is the time to felicitate the people who have put such immense amount of hard work, vision, planning, dedication, and whatnot. Time to felicitate the organizing committee. Please put your hands together for the organizing committee members. And we would like to, first of all, felicitate the chairman IRIA Northern Region, Mr. Mukesh Kakkar. And to do the honor for him, may I invite on stage Mr. Sanjeet Sarkar. A big round of applause, everyone. Mr. Mukesh Kakkar, sir, please stay on the stage, sir. Please stay on the stage. Now I would like to invite Mr. Jitendra Bhatia to felicitate our chief convener, Mr. Ashwani Sareen. Big round of applause for Mr. Ashwani Sareen. Thank you. I request Mr. Ashwani Sareen to please stay on the stage to felicitate other organizing committee members. May I invite the Vice President of IRIA, Mr. Indra Parekh. All right. Please put your hands together for Mr. Indra Parekh. Now I invite Mr. Saurabh Malhotra. Mr. Saurabh Malhotra, convener of NRC 2024. Big round of applause for Mr. Saurabh Malhotra. Now let's have the Vice Chairman, IRIA Northern Region, Mr. Nipun Jain. Dr. Shobha Dhawan. Mr. Sanjeev Sikka. Let's welcome Mr. Sanjeev Sikka with a big round of applause. Mr. Vipan Mehta. Big round of applause for Mr. Vipan Mehta. Everyone, please put your hands together. Now let's have on stage Mr. Anay Gupta. Big round of applause for Mr. Anay Gupta. Mr. Surinder Paul Gupta. Okay. Mr. J.S. Rangar. Mr. Subhash Jain. जोरदार तालियां हो जाएं, everyone. Can we have Mr. Navneet Gupta? जोरदार तालियां हो जाएं नवनीत गुप्ता जी के लिए. Now let's welcome on stage Mr. H.K. Pahwa. तालियां बजती रहनी चाहिए because these are the people who are the force behind this wonderful event. Mr. Anil Arora, Mr. Naveen K. Garg. Big round of applause. May I call Mr. Saurabh Malhotra, please come on stage for felicitating the members. Convener. हाँ, सौरभ मल्होत्रा जी को बुलाया है, वो भी फेलिसिटेट करेंगे. मिस्टर संजीव कुमार जैन, तालियां हो जाएं जोरदार. मिस्टर संजीव कुमार जैन. मिस्टर रवि गुप्ता. Big round of applause for Mr. Ravi Gupta. Mr. Rajesh Duggal. Can we have Mr. Rajesh Duggal on stage? Mr. Binni Satija. नहीं है? Okay. Mr. Amit Agarwal. Mr. Anshul Sareen. Big round of applause. जोरदार तालियां हो जाए मिस्टर अंशुल सरीन के लिए. He has worked relentlessly for this beautiful and flawless event. Mr. Varun Agarwal. Big round of applause for Mr. Varun Agarwal. The youngest member of IRIA Northern Region.
Varun Agarwal is Lal Bahadur Shastri of Northern Region.
क्या बात है. Mr. Anil Kakkar. Let's welcome Mr. Anil Kakkar on stage. Okay. Moving on, Mr. Harpreet Singh. Mr. Harpreet Singh. तालियां हो जाएं. Mr. Harpreet Singh. Mr. Anshdeep Chadha. Mr. Rajendra Thakur. Mr. Vivek Gupta. Mr. Anshu Chabra. Okay, Mr. Vivek Gupta. Big round of applause. Come on, everyone. तालियां हो जाएं.
We're gonna rock this place.
Anshu Chabra is not here, right? Okay, okay, he's here. जोरदार तालियां हो जाएं. I request Mr. Anshul Sareen to accept the memento on behalf of Dr. Samar Bandopadhyay. Big round of applause for Dr. Samar Bandopadhyay. Mr. Amardeep Singh. Can we have Mr. Amardeep Singh? Big round of applause. Woo! Mr. Jitendra Bhatia. Can we have Mr. Jitendra Bhatia? Okay, he's coming. Big round of applause for him. Woohoo! Mr. Naveen Jain. Mr. Naveen Jain. Okay. Mr. Rajiv Pandey. He's the Regional Secretary, Northern Region. Mr. Rajiv Pandey. Mr. Arjun Narang, Account Executive. Okay. Mr. Mohan Gonyal. Woo! Big round of applause for Mr. Mohan Gonyal. Miss Shweta Khanna. जोरदार तालियां हो जाएं मिस श्वेता खन्ना.
Ladies and gentlemen, may I request Ladies and gentlemen, now may I request team, our hospitality partners, team from Hotel Le Méridien for their very kind support. 24 hours, more than 24 hours, they have been with us and they have done each and everything we needed from breakfast to dinner to next day lunch. And please, आप लोगों ने जो भी food enjoy किया है वो सिर्फ Hotel Le Méridien की वजह से. Thank you so much. May I request all the team members, please, to come up on the stage? Thank you once again, Hotel Le Méridien team. Now may I request our now may I request our chairman, chief convener, and convener to please award a special guest for Shri Vishnu Namodri ji.
Big round of applause, everyone. जो लोग भी हैं.
माना हम थक चुके हैं, बट हम तालियां तो मार सकते हैं. Please.
तालियां बजाइए, come on everyone. हाँ, निकली. क्या नाम है? क्या अंश? हाँ 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 वही मैं तो.
We would also like to thank our event partner, Anukriti Events. Ansh Anukriti Events, our event partner. Big round of applause for the team of Ansh Anukriti Events for beautifully putting this event together.
Ladies and gentlemen, now I am requesting you all to give a round of applause for our MC, Miss Kalpana Mishra ji, who has worked so hard for this event and made this event a big success. And may I request, can I request our chairman, please? Can I request our chairman, please? Can I request our chairman, please, to give a memento to our MC, Ms. Kalpana Mishra ji? Thank you so much, Kalpana.
Thank you, Anshul, for having me. Thank you, the entire team of IRIA. Thank you very much. Let's have a group picture. Let's have a group picture. Everybody, please come on the stage for a group photograph. Let's conclude the National Rubber Conference 2024 on a high note with big smiles on your face, and let's be back together again in the coming year. Thank you, everyone, all the sponsors, organizers, hospitality team, everyone. Thank you and congratulations on the successful National Rubber Conference 2024. And here we conclude the conference, but we meet for networking and connection. Have a great time ahead. Great evening. Thank you very much.